All right. So one thing we're going to do it is anything that we talk through the lectures, we'll record it so you have an opportunity to go back and listen to that also. Let's first talk a little bit about the logistics. So we're going to meet it every weekend. Typically, like if we start sharp at 9 o'clock, so I would recommend that let's be here by 8:45. And then we go through till like 1 o'clock. And so that will be both Saturday, Sunday. There will be probably a day during this one where we'll probably start a little bit early and then go a little bit because the topic is big enough and we don't want to break it across 2 different sessions. Yeah, but other than that, one day, we'll be doing that. And then most of the material that we talk about, the new material, will be taught on Saturday and Sunday. And then every Thursday, we'll have pretty much a review session where we're going to focus on your homework. So Harshal and I kind of like a little bit old school, along with the work that you will do it in the class, you will also get a homework assignment, which will be like it's doing the work, because we want to make sure that whatever you learn it, if you don't practice it, you tend to lose most of that knowledge. In fact, like it research shows that if you're not up to speed or don't use it within the 3 months, you lose 70% of the knowledge. So the goal is for you to continuously practice what we talk about it at also home. And that's what typically we do it on Thursdays. And Thursdays is all online on Zoom. And we go for about a couple of hours starting at 6:30. Okay. Now, during the daytime, on Saturday and Sunday, while you are here, what you're going to see is we'll probably go hour and a half, and we'll take a break. We'll take a break for an hour and a half. So, Marshall, when you signed in, it kicked me out. It's still recording. Like this morning is full of technical issues. So we'll go for about an hour and a half, take a 5-minute break, and then continue. What you're going to see it in the first probably couple of lectures, it's going to be a lot more lecture heavy because we're going to try to set it up a baseline for everybody. And from there, what you're going to see is probably half an hour lecture, and most of them is a working time where we'll actually practice everything that we learn it in the class so that you can refine it more of that at home. All right. So let's quickly look at it. Like I heard it about everybody's desire and the background to start working in the IT field. Okay. So give me a little bit about the background in terms of objective. So Harshal and I kind of went started it. As he indicated, we have a lot of experience teaching it. In fact, like most of the things that I started teaching goes back to the 90s. One of the key things that we've both seen it is most of the college and the university stuff, it's a lot more heavy on the academics. It has been transitioning to a little bit on hands-on. However, when we set it up this thing about like it's 7 or 8 years ago, our focus was to build the things that essentially gives you a real life experience. So what you're going to see is we're not just going to explain and talk about the software quality assurance and the testing terminology and what all you need is. But one of the things we're going to do is we're going to expose you to the real life projects. So it's the real projects that we have worked with for our clients. We're going to get that as an assignment and then work through that. So you will get a fully exposure of what you will do it when you go into the workforce on a day in, day out.
So have you guys seen the movie, I don't know, it's a Hindi movie called Drishyam, right? So the same concept, okay, in the movie, they rehearse, but they actually go and do it themselves so they can speak about it. Same thing you're gonna be learning in this camp. You will actually work on the actual IT project. What you do day in and day out as a QA, that's what you're gonna be doing and producing the artifacts. When it comes to the interview, you can explain exactly what is that you did in the projects and how it works and do it.
Right. This is a more like an eye chart in terms of it. Over the course of the 12 sessions, you're going to learn a lot of technology and a lot of tools and a lot of terminology. So let's start it with the basics. Any questions before we start? The way I like to teach it is, if you have any questions, stop me there, ask it. If there are things which is coming soon, I'll tell you to hold on for a few minutes. Otherwise, it's important to have that understanding right there. All of you also has a folder in front of you. And for online legal and affiliate, you should have a software version of it that Harshal is sending it out. So you will get soon. So
I'll be sending them in 5 minutes.
Okay.
So that they have a copy online.
Okay.
And I think we have new student join, Vaibhavi as well online. So CC is from Canada.
Okay. Welcome, Vaibhavi. So we're just about to start, and what we'll do is after the first break, we'll have you introduce yourself so that everybody else in the class also knows a little bit about you. So what I want here is like, if you have a question, most likely somebody else in the class also have a question. So don't hesitate, don't hold it, because the main reason you're here is to learn. Now, let me ask you guys a question. Is my voice coming out clear? Okay, because I'm not too comfortable in terms of speaking out very loud with the mask on.
Yeah.
No, I'm fine. It's not that, because at the work also, I can wear the mask all day, right? But there, I'm not like it's talking in a big room. I'm just in a, like it's more in a closer session. So what are we going to do is we're going to talk about the basics. First, we'll start with what is a software and some little bit about architecture around it. Okay. What we want to do to get it out of that is that you will be able to explain clearly what is a software and how the software is built. Okay. So what you're seeing on screen is a definition of a computer software. You can read it, it's from Wikipedia. But more importantly, if you think about it, it's a set of instructions that you are giving it to some sort of hardware to execute it. And the results of it essentially gives you some of the productivity aspects of it. Okay. So question is, why learn software? So if you look around you, right, pretty much in every aspect of the life, software is there today, right? Starting with the phone that you have. Most of you have some sort of a gadget which essentially allows you to interact, like it's whether it's a Alexa device or a Google device, or trying to do a search on the internet. Okay, everything that you do nowadays, it's kind of have some sort of software element into it. Okay. So if you think about it, right, whether you're trying to do a budget, we talked about the internet search. One of the big area where software is kind of heavily utilized is gaming, right? Or social medias, like processing pictures, posting things, posting videos. All of them are nothing but an example of software helping you to perform certain personal tasks. Okay. Let's talk a little bit about the overall overview of a software. So what I want you to think about it is a visual diagram. Okay. So when you think about software, okay, think about a box. Okay. At the bottom of the box, you will have a hardware. So I'll give you an example. This is the thing that you touch and feel it. Let's say if you are using phone as example, this is the actual physical device, is what it's hardware. Okay. Or if you're using laptop, iPad, whatever you're using. On top of it, there is a software layer known as a system software. And the way the system software communicates with the hardware is through something known as a firmware. Okay. The black one is covering it.
Yeah.
Okay. So on top of system software, it is the communication. Okay. So everything that you touch and feel is hardware. It has a small component called firmware. So if you look into it, if you open up any hardware, you will have some chips in there. Those chips are nothing but it's a way, it's known as a small piece of software on it called a firmware, which essentially drives all of the function of what needs to be operated. Right. And on top of system software, something known as application software. So let's take an example that we're talking about the physical phone, right? So if you want to make a phone call to a friend, right? What do you do normally? You start up an application, right? You bring up the phone application or the dialer number, right? And you dial the phone number on top of it, and you press the dial button, right? So there's a green, you will have some button like this, right? You press on that, it comes up, you press the number in the dial. So that layer is essentially an application software. If you want to utilize a different software to make a phone call, you can download and install on your phone, right? Whether you want to do a WhatsApp or you want to do a Google Voice or the native application that comes with your phone, right? Whether it's there or not. So those things are nothing but an application software. Okay. And that application software then communicates with the system software. So if you're using it, Apple, right? You know something like called as iOS, right? iOS is nothing but an operating system or a system software that manages the actual device. Okay. So that phone that you try to dial the number, it goes to the system software and says, okay, I need to make a phone call out. Okay. That system software then says, okay, I understand that what you want to do it. It converts that particular phone number and things that you dialed it into specific underlying firmware call. Okay. And that firmware instructs the hardware saying, okay, send out this particular signal to the tower. Right. Or if it's like it's a voice over IP phone, send out the signal as the data transmission over this hardware to going over the Wi-Fi signal. Okay. So your software, the instruction that you gave it, interacted with system software that then converts it, that goes through hardware. Now, when somebody responds it, the hardware gets that information and they convert that into calls going into the system software through the firmware. which in turn gets converted to application software. Now, this is the basic architecture for no matter which computer you use. Okay, it will have some application software running on something known as operating system, right? So example here is we talked about iOS. Another example is Windows, right? Mac software, depending on whatever you want to use it, right? If you're like it's a Google devices, then you get it Android software. So all of those are designed to work specifically with the hardware. Okay. This essentially allows you two purposes, right? When you look into the application software, typically, whether your phone, let's take an example of WhatsApp or Instagram, right? It'll run on any of these devices. But you all have to worry about is interaction with this one. You don't have to say, hey, if I'm working on iPad, I need to interact with this one because it's a different hardware, a different screen size. Versus if I'm using on my phone versus on my laptop, it's all different screen and devices. System software takes care of all of those things for you. And then the hardware is the one which actually processes those images. Okay. Now, a lot of times you will hear the word as, what is the platform that you're using it for your application, right? So typically, like it's this thing is known as a compute platform. So essentially, what is the hardware you're running it, and what is the operating system that's managing the hardware? Okay. So this is the basic architecture of any computing system. Any questions? All right.
So, like, I'm not clear about the firmware. Is it the platform where, like, if we are sending some code to a system, so that is the place where that code will be like written on the computer?
Yeah. So if you think about it, you see those chips, right? So those chips essentially has a signal because somebody has to dial this 8. Let's say if I'm trying to dial number 1, 2, 3, 4, 5, 6, right? When you press 1, somebody has to say to the hardware is that, hey, this is a 1 versus a 2, right? It generates a different signal. So essentially the system software invokes a firmware is a very specialized software. Okay, and that software essentially has a direct signaling mechanism on the motherboard to the hardware. Okay, so you did an electrical system, right? You said you did an electrical system in the background, right? So have you done the digital signal processing?
Yes.
Right? So that's nothing but DSP, right? So you go over a specific wavelength and then you overlay things on top of it. So this firmware tells you what to overlay and the hardware overlays it. Okay, so somebody at the software level, system software level, the way only they interact or gives the signal hardware through this firmware. Let's take an example, right? So everybody heard about Tesla, right? Electrical car, everything is controlled by computers. Okay, so when you make a command that accelerate, because in this case, the speed limit in this particular area has gone from 25 to 35, and I want to accelerate, right? So application software, which is the mapping software, knows, hey, the speed limit is now, I can go a little bit higher. So it needs to accelerate. So that application gives the command that accelerate it. The Tesla has a inbuilt car OS system, which essentially takes it, oh, you want to increase the speed. Well, then it converts it and gives a command to those electrical component, which is residing on it. And those electrical component has chips on it, which is programmed to interact with that particular command of whatever the system software is. Right? So that essentially drives it, the hardware. So the firmware is nothing but a specialized program that it's a very, so I don't know if any one of you have ever done or interacted with it. Maybe you might have done it during the electrical thing, something known as a firmware. Well, I'm losing the specific thing. It's a hexagonal instruction.
So you mean to say, like, whenever we give some instruction to the hardware, to the system software, so the thing like that converts those instructions to 0, 1, that stuff, that is the place where
this is where it happens. Okay, but this is system software interacts through something known as the hex codes, and that hex codes get converted into bits and bytes. Okay, but again, you don't have to worry too much about it. That's a deep into the computer architecture. Right? And then that's depending on the reason why you need to worry about different system software interacting with it is depending on the hardware, everything is specialized. So take an example, right? So when you are driving with a Google Maps or GPS systems, there is a user interface which talks about all the application. But at the end of the day, that they have to coordinate with the GPS coordinates and then put wherever your location is onto the map. So you can see it, where you're moving it, what is coming it next, right? So that's how the direction comes in. And all of the location coordinates and GPS comes from the hardware, which converts that. And those signals are picked up by system software and they overlay on top of your location. Okay. Again, 95 or 98% of you will always be interacting only at this layer. Okay. Very few of you, if you want to do a specialized testing and all, you might interact with them. Unless you're in a very hardware design, you will never interact with the phone. Okay. So most of our scope, we're going to focus on here, because that's where you need to first able to test it and validate and understand how the software works. Okay. Good with it? Yes. Okay. Let's get out. There's a way to minimize this also. All right. So we talked about the system software, right? It's a software that coordinates the functions of hardware. And on the one side and the other side interacts with the application program. Okay. So application software is where your domain is going to be. Those are the ones which are productivity related software. So if you're doing it computer image processing, right? So you will have a photo software on it. And typically the way you know it's an application software, it's something that you can either download through the internet or through an app store or through a device, whether it's a USB drive or if you were around 10 years ago, it used to be a floppy drives or CD drives or DVD ROMs. Nowadays, most of them is coming through the network storage, which is over the internet, or through a device which is connected through USB. Okay. So the key purpose of the application software is the productivity. Okay. So anything that you're trying to accomplish, it's going to be on the top layer into that 3-layer diagram. Okay. And all of you have interacted with some software at some point, so you exactly know what productivity software is. Okay. And then again, the key interaction layer for application software is the system software. All right. Now let's focus on the application software itself. Okay. When you're going to look at it, the type of application software available, you're going to see it, you can categorize them broadly into 3 categories. Okay. The first category is a proprietary software. It's a one of a kind software that is developed and owned by a single company. Okay. So we talked about Tesla, right? The software that controls the Tesla car is developed by the Tesla. It's a proprietary system of a Tesla. Okay. I can just go and say, hey, you know what? Let me build my software and put it on Tesla, right? But the same way, you know that you can pick up a Tesla software and then put it into another car and expect it to run the same way, right? So it's designed for a specific application. In this case, driving a specific vehicle, and it's developed and owned by a single company. So it's from intellectual property point of view, they own all the copyrights for that particular software. Okay. Another example you can just say is when you do it, aircraft control systems, like missile systems or rocket systems. All of those things are specific to one kind of application. The second category you can think about is off-the-shelf software. Okay. So you take this software, provide it, and you can install it into multiple devices or device. So let's take it Microsoft Office, right? I can just go to a store, whether it's a Best Buy or Amazon. I can purchase it and install it, right? I don't need any specialized hardware to run. Right? It will run on a wide variety of hardwares. It will run on a wide variety of platforms. All I need to do is pick it up from the software, from the shelf, and use it. Another example is the tax software, right? Coming March, Uncle Sam wants to take its share, so all of us has to go file a tax return. And then we use some sort of either TurboTax, tax cut, or a Chino type of software. That's another example of the off-the-shelf software. Say that again.
What was the example?
The tax software.
The what?
Tax software.
So like TurboTax.
TurboTax and things like you pay the money for. Almost all the applications that you're using on your phone, and you can download it from the App Store or Google Play Store, they're off-the-shelf software. Right? It'll work on any of the phone which is designed for that particular operating system. Now, the third category of the software is something known as open source software. So the proprietary software or off-the-shelf software, you still have to pay the money. Most of the intellectual property is going to be owned by a given company or the company which has built that software. In contrast, open source software is built by community, and it's kind of more or less kind of free for you to use. Okay. You can use it for free as long as you abide by certain rules. Okay, and that's something known as end user license agreement for the open source software. So take an example, like it's as you go into, you will start hearing it something as Java programming language or a database management systems. Those are nothing but an open source software. The people have built it, give it to the community, and then community now owns it and updates it. And one other extreme example is all of you has used some sort of either WhatsApp or Facebook or Instagram and all, right? All of them are owned by Facebook, and the whole distributed management system, so how that particular application supports the users worldwide, Facebook has made that software as an open source. So if you really want to get into it, you can just get into database management or data center management software, and then build your own on top of it. Okay. The whole purpose here is something is working, it's kind of more, they want to like it's more to be adopted by the community, and the community picks up and do that. Another big example is Google's Android operating system. You can actually download the whole Android operating system, so you can customize the way you want it for your phone. You don't have to follow whoever is your provider, whether it's AT&T, T-Mobile, Verizon, or any other provider. Okay. So that's the power of open source software. So typically, whenever you are interacting with the type of an application software, it's going to follow broadly into one of the three categories. Okay. Any questions on three categories?
So do you think over the period of time, can proprietary software can become off-the-shelf software, and like off-the-shelf can become open source software, or will it stay like that?
So it can go from here to here, but it's not simply that, hey, I just gonna give it free. Like proprietary software is essentially typically designed for a specific hardware. But unless you go ahead and enhance it to work with all the other hardware, you can't go from a proprietary to off the shelf. Okay. Same way from off the shelf, if you want it in open source, you still have to make some changes to the software in order to get it more in a publicly accessible life. Okay. So yes, you can migrate it from this way to this way. Potentially, it's harder to migrate from this way to this way because of the property that everybody has it in terms of utilize it in open source. But you can take an open source software, wrap around with additional services, and call it off-the-shelf software. You can do that.
Okay.
Yes, Vaibhavi, you have a question?
Yeah, hi. So can you give more example for proprietary software, please? Is it an okay? I just want to know more. Like if you can give example.
So let's talk about. Do you use phone? You have Apple phone?
Yes. Yes.
Okay. Apple runs iOS, right?
Yes.
You can take an iOS and install on an Android device or a non-Apple device. That's a proprietary software.
Okay.
It's designed specifically to run only on the Apple hardware. Okay. You can take an iOS and make the changes because it's all of the software and the intellectual property rights for an iOS is owned by Apple.
Okay.
Does that help?
Yep. Yep. Thank you.
So now let's talk about software architecture. Okay. So the way the software is built using components. So there are multiple pieces. So when you talk about the phone, right? Your phone is designed to do multiple things, right? You can make a phone call, you can check emails, right? You can take the pictures, but there are multiple tasks. So each one is going to be having some sort of what's known as component or core functionality, and that interacts with something else. Okay. So whenever you talk about an architecture, right, let's take out the word software away for a moment. Whenever you talk about architecture, it's a design that talks about how the various components are there and how do they interact with it. Okay. So let's take an example of an architecture, right? If I'm building a home, right? The home is made up of multiple components, right? It's an architecture, right? So it has a frame, it has a foundation, it has an electrical system, it has a plumbing system, right? And it has a air circulation system. each one is designed to do certain specific tasks. But you can't just design it completely independent, right? So your electrical system has to interact with your foundation as well as your frame within the house, right? So you can't just have a wire line everywhere. You need to run it specifically where, even though it's an electrical system, it interacts with the framework in the house. Same thing with the air duct system, right? You have to design certain way to fit into the frame. And then now you need to have your air circulation system. If it is through the centralized AC system, centralized heating system, it needs to interact with the electrical system at some point, right? Same thing with the plumbing system. So you're always going to have, when people talk about architecture, there's various components in the way that they interact. But now when you think about it, electrical system, it has a specific purpose, specific features, capabilities, right? So every component it's going to have its own property or own functionality that they provide. Same with your software architecture. It's typically made up of multiple components. Each component has specific roles and responsibilities or feature or capabilities. And they interact with the other component in a specific way. So they have a relationship and interaction points. So when you consider all of those things together, it is what are my components, how they interacted, what is the relationship to the other components. That's nothing but a software architecture. Okay.
So in a simple language, can we say like all set of three components like the application software, system software, and hardware, they all, how they interact with each other? Is that the?
That's a one level of architecture. That's a computer architecture.
Okay.
So that's essentially how everything works together in synchronized. Now you take each one of the components, right? You take a hardware layer. Hardware layer is going to have multiple components, right? So when you consider a phone, it has some sort of antenna, right? Which sends a signal out to the cell tower and gets back from the cell tower. It also has some sort of memory, right? It contains the memory. It has some sort of core processing unit, which takes that image and processes and all those things. So one level of architecture is how each one of those components work together, because they need to interact, right? When I try to retrieve an image, right? It's stored in a hardware, it's stored in memory somewhere, it needs to be pulled it out, right? And that the CPU has to process on top of it to make the changes that you wanted. So that's a one level of architecture. System software itself, how it interacts with the hardware, right? That's a relationship between the compute platform, the two components, right? You can say system software is one component, hardware is another component, and how they interact provides a compute platform. So that's the second level of architecture. And the third level you can put it is how the application utilizes the software and the hardware to do that. However, within the application, right, you may have multiple components as we talked about. So when I want to do it, let's say a photo processing, right? You're going to have the actual image. You may have a component that said, hey, let's load the image and then save the image, right? And it may also have, let's just put a cropping function on top of that, right? That essentially adjusts the whole software of how it, or image of how it needs to be looked at. You can put additional filters on top of it. Each one has specific components, and how the filter works with the image, it's a relationship, right? So all of those itself, within the image processing software, there are multiple components and they interact. So the way that software itself is built has some sort of architecture, right? And we'll look into a moment of what are the different architectures and things like that. Does that make sense? The overall? Okay. Now let's talk about the software architecture. Okay. So when you think about the architecture. Okay. Things doesn't say static, right? It evolves over the time. So let's talk about the house, right? Let's keep the same example as we go through it. Do you believe the house, the way it was built 2,000 years ago, it's the same way it's built today? No. Right? As we learn things, as things built or developed, right? The way the houses were built evolved. Okay. So when you look into a certain era, right? So for example, if you go out into the various remote areas, right? Where there are historical houses, you can go look into it, right? Those houses still exist today, right? The structure is still the same. Versus if you go into modern downtown areas, right? Or multi-story penthouses, the structure is different. Okay. So things evolve it over the period as you learn it. And as more and more things are available in the market to essentially construct that particular thing. The same thing with the software. Originally, software was built in the early 30s, 1930s, because we are almost to 2030, right? So over the last 90 plus years, the way the software evolved has changed, right? In the early days, software was a privilege, right? The big companies or big government are the only one which will have computers. Versus nowadays, everybody can have computers. Like in fact, the phone, which is on your palm of hand, is nothing but a sophisticated computer. In fact, it has a more power than what was used to send a man to the moon. So think of that for a moment. Not only just the size, but the power and capabilities also kind of evolved significantly over. And along with the hardware, the software also evolves economically. Let's talk about some of the architectures. All right. So the first architecture, when it was built, the software, it was more monolithic architecture. Okay. So there are two pieces of key element whenever you think about a software. One is the actual data, right? That you give it or you get it from the software that you're going to process it. And the other part is the code or the processing instructions, right? So let's say if I'm doing an image processing, right? So my actual image is the data, okay? And the various things that I put it on top of it to process that, to make it a black and white or crop it, they're nothing but an instruction which tells it, operate on this data to do this task. Okay. So whenever you think about the computer software, there are two aspects that you would think about it. One is data and one is the code or instructions. Okay. In the early days, when this computer was built for initial sets of applications, everything was residing in the one place. So all of your code and data resided together. Okay. So I'm kind of sort of more science buff and space things, right? So have you seen a movie called Enigma? Okay. So Enigma is essentially a true life story of how the system was built to crack the German codes in the Second World War. Okay. So during the Second World War, Germans will change the way that they code their messages once a day. So Allied forces, which was trying to listen to those signals that was coming out from German, specifically U-boats and the German air forces, will change every day. And they needed to figure it out. Hey, how do I decipher that message to actually truly understand what is being sent. Okay. So Enigma is a movie around how Alan Turing and the UK intelligence actually build a computer to crack that code. Okay. In that, this is early 40s, late 30s, right? So you will see a truly depiction of what it means to be a monolithic architecture. It was a huge room where all the computer processing were there, and they will take the code and they will manually take the signal or the message that they intercepted and manually enter into that. And that's everything was residing in the one room. All of your data as well as instructions. So it's all compact. Another typical example was the early days of mainframe. So if you think about it, early days, you can't access the computer from anywhere. You have to actually drive down to that building and go into that particular floor and then interact with it. That's a monolithic architecture. As things evolved, the businesses started understanding the importance of the computer brains, right? So, perfect example. I think some of you have some exposure to the banking, right? And I work definitely in one of the biggest banks in the world. So when you think about banking, right? Those days, and I don't know how many of you remember, but I'm once as I'm old enough that I remember those days. But you actually have to go to a bank to do any sort of transactions. Whether you want to get the money out or deposit a check or check the balance, you actually will drive up. And then when you go to the bank, the teller will have a big green terminal. Okay. So if you watch some of the old movies, you will see those terminals. But those terminals were the dumb terminals. All they were doing is an input device and output device that was connected to something called a server. That's where all the main computers were. So you build in something known as client-server architecture, where your main computer can be now connected by multiple endpoints or multiple clients. All those clients will send a request. The server will process it and send back the response. Okay. Now, if you think from a software point of view, right? Let's talk about the evolution from here to there. All I have to worry about it is, do I have the right sets of data and do I have right processing instructions? That's all I have to worry about it when I'm doing a testing or writing a software, right? So if I do a 2 + 2, does this instruction gives me the answer 4? And do I have the ability to enter 2 and a plus as the output? Right? That's all I have to worry about. Now, as I move to client-server architecture, if I'm a software engineer or a quality assurance person, now I have to think about it a little bit differently. What if I send this a request? I need to make sure the response goes back to the same guy, right? Just imagine if I'm a banking customer, I want to deposit $1,000 and the server deposits in somebody else's account. How happy I will be, right? So you need to start as a software engineer. You need to now start worrying about, hey, is this request is coming from a terminal and is the response going to the same terminal or not? Right. At the same time, I had to worry about processing multiple requests, right? So I have to do some sort of trafficking. The third thing I have to worry about is now, what if this connection goes down? So let's say I send a request and my connection to the server is lost. What do I do with the response? What does this guy wait forever to get a response, right? I have to start worrying about testing those scenarios or validating as a software. I have to deal with handling those scenarios. Okay. So from 1930s and 1940s, reach late 1950s, went from a monolithic to a client server architecture, right? The software needs to be evolved with that. Okay. Now I have two different sets of software, right? Server software and client software. Then I would not even say early 70s, when things started evolving, people started understanding it as a corporation, right? What is my most important asset? Is it the applications? No. It's my customer and their data, right? So if you look at it nowadays, you start worrying about, hey, there are breaches happen and 10 million customer information is out. That's my biggest liability. That's my most important asset, is the customer data, right? My applications are nothing but taking that data and managing it, my relationship with my customer. So think about saying we're banking customer. Okay. So if I go in, right, the banking software, which essentially allows me to deposit or withdraw the money, that's not the only thing, right? My most important is, what is my accounts? What are the products I have? And what are the attributes, right? So how much balance I have in my account is the most important. Can they offer different products on top of that data? Yes, right? You can have a checking account, you can have a savings account, you can have an investment account, right? The data is still the same. Depending on what you want to do with that, you will give it different applications that interacts with it. So they started realizing it is that in the scenario here, where all the server was maintaining all the data and application software, right? And think of this one as a presentation, right? Because it was just presenting something and getting back something. You already separated it out, but I need to worry about now my logic and the actual data. There are two different entities and two important things. So they started layering it out and said, just keep the data separate so we can build the new applications, new products, new things on top of it. It's a business thing, right? So that's when you started evolving with something known as database management systems, so data systems. Okay. So now I have to worry about building an application which protects the data or manages the data with an application tier. That's where my business logic or my rules engine and things like it's going to happen. So I could have the same data and build different applications, right? Some companies or some banks doesn't allow you to overdraft, right? So the only time of money I can take out the money is if I have it in my account. Some companies or banks offer you to overdraft. So even though I don't have sufficient balance, I can take out some money. So there is, depending on what rules are wanted, my application is different now. The data is different. And then obviously we talked about the presentation here, right? Which was in a client server. It was a client aspect of how my data is presented. But as the mid-70s started coming, the terminal types have started different, right? You will have a mainframe or main terminal. You will have a remote terminals where people can start accessing it. And some of the advanced governmental agency or industries have started something more of a mobile device. And if you see those mobiles, that's way different than the mobile today. It's huge terminals that carry on it, like older laptops, which is like, it's probably good enough, like 20-pound laptops. Okay, but I still need to plan for this interface for those. Right. So the software started evolving, which was broken down into 3 different layers of component: user interface, application component, data component. Then early 90s started coming in, and things started going into internet. Berners-Lee essentially enabled an internet, and companies started offering their business more online. That means now I don't have to think about limiting the number of customers, right? So if I was a bank earlier, the only time I had to worry about is how many tellers I have it and how many people can at a given time walk into the bank and do the teller, right? Not many. I don't have to worry about too much. I can manage the processing in that. Now the things change. Everything is online. So I can start potentially have a lot more clients interacting at the same time. Right? So now there is a limitation that comes up. Okay. And I want to think about a visualization picture before you can understand this. Okay. So if you look into the way all of the memory is attached to a computer, okay? So you have something called a CPU, which resides on a motherboard of your device, whether it's a phone, computer, a laptop, iPad, right? It has all those devices. Along with the CPU, they have certain thing known as L1, L2 caches. Okay. These are a small set of memory, which is fabricated into the same chip as the CPU. Okay. And the communication, this thing, this happens into the order of 10⁻⁻⁹ seconds. So nanoseconds. It's instant. Any data which is present here needs to interact with computers and instant. Okay. However, this is very expensive. There's a physical room, there's only a little bit. So these are typically like it's 256K, right? When you consider your picture that you take it on your phone, typically if it's 8 megapixel, it's about 4 megabytes. Versus this is about 256K or 128K memory. So you can think about it, it's very small set of memory. Then they have something known as a RAM. So when you buy a computer, right, they'll give you a specification. That's 6 gig RAM or 8 gig RAM. Okay. It's a set of memory which resides on the same motherboard, but it's not on the same chip. So if you open it up, right, you will see two different chips. One is the memory chip, one is the processor. So this is the second chip, right? So this is typically, usually now it's in a gigabyte, anywhere between 4 to 16 gigabytes. Right? And when you go on high-end computer, it's 64 gigabytes, but that's what it is. Now, when computer has to commute, they don't communicate directly to the RAM. It goes through this memory and goes to here. Now, this access, right? So let me do this. This is access is 1,000 times slower. So when you look into it, it's 10⁻⁻⁶ seconds, right? Which is essentially, and then not. 3 is a milli, so this is a nanosecond. Okay. Obviously, but not everything is sufficient in the 4 to 16 gig. Like you get at some point, you're going to run out of that memory. So I need to put this memory into some sort of device that will store it for a permanent and for a longer duration, and it has a bigger capacity. Right. So this is where you see it hard disks. Right. So now it's a solid state. Earlier it used to be a spindles. Right. So this can store some sort of nowadays a terabyte. Tons of spaces, right? Anywhere between 512. Typically what you see it in solid state is 512 gig. Some are like 1 terabyte or 2 terabytes. This one, it's typically milliseconds. So you will see it, some specification, it will spindle device at 7,200 RPM. That the device spins that fast, and that's how fast I can store the data. Okay. And then Big corporation have millions of customers. Terabytes is not sufficient. It has to be in what is known as petabytes and petabytes. So they just do it offline, right? So an optical disk or some sort of other where they burn it and keep the data. And this one is typically 10 to minus 2 seconds access. So as the things comes in, the closer you are to the CPU, the faster data is. Right? The further away you are, the slower. However, closer you're to the CPU, your essentially capacity is a lot more smaller, versus further away, it's a huge capacity. Right? So if I'm a big company, I can't just say, let's just make this an infinite, because it's inexpensive. Okay. So typically when you look into the dollar amount, right, this is a fraction of a cent. Okay. Optical disk data. This is typically like it's anywhere between 30 to 50 per kilobit. So you can think about it, significant cost difference. So you can't just afford it even financially to say, hey, I'm going to drop and put everything in the memory. Right. So you have to do somewhere the balance. Right. That's why you see the different tiers of memory. Okay. Now the reason I say that way is, as the 90s came, right, the internet started coming in. So your customer base started exploding. Right. So think about Amazon. Okay. Think about like Black Friday. How many transactions they need to do it? They have over 300, 400 million customers. All of them, or let's say some logic, 10% of them just log in, which is reasonable, right? On a big day, 10% of the people, 10% of your customer log in. That's 30 million people logged in. Just imagine 30 million transactions you need to handle at the same time. Right? Typically, everything that CPU interacts with is either in the RAM or it's in L chip. How much things I need to worry about? Millions of customers, millions of transactions. I need a huge capacity. So the architecture started coming around and says, wait a minute. It's only 10% of customers. So all I have to do is not try to bring all 300 million customers. I need to just think about only those customers who are currently active and keep only those in the memory, because if I'm logged off, I'm never accessing these things for a given time, period of time. So they started thinking about and breaking it down. The data tier, which was this tier, and said, you know what? I can break it down. Everything doesn't have to be here, nor everything has to be here. What if I can identify a way of what goes from here to here on a timely manner? Right? So that's where you started seeing this level of architecture. So this one, I know you can't see it. I can't drop it this thing anymore below. Here. So this was your original database, right? So this typically it's your hard disk for this. This was fairly slow, right? And they said, if I process 30 million transactions, I better be fast. Ideally, I want things to be here because it's in 10⁹ dimension. So they started saying that, hey, what if when somebody is accessing their data or somebody is performing transaction, I'll bring their data from the database, which is this layer, to the memory. Okay. So they just bring it into what is known as a data access layer. And then from that point onwards, your business layer just interacts with the data which is already loaded in the memory. So I don't have to incur a 10⁻⁶, which is 6 times or 1,000,000 times slower in terms of accessing. Okay, so they broke it down. Anything that needs a permanent storage, but it's not currently actively used, it will reside here. Anything which is currently active will stay here. And then once they're done, they will push the data back in here. Right? And if I'm full, they implement the logic. But it says, okay, who was least used in terms of time loss? Let me push that data here and bring the guy who needs access now. So there is a software that we need to start managing this way now. This one is already a business logic, right? But in the 90s, the personal computing started picking it up, right? So you're going to start having it, people using more laptop. There was a lot more common personal PCs. Windows came in, right? Apple started with the 2nd generation. And some mobile phones started showing it up, right? Whether you believe it or not, iPhone was not the first mobile phone. There used to be an HP and a Windows phone before it, what we used to call a brick, which was 2-3 pound heavy. Okay. Okay. So I have to start now worrying about different layers. Another thing, another thing started coming out is people through internet accessing things from home, right? So now my presentation layer has to adapt to different screens. It was not just somebody walking into my branch and trying to access it through the table or all of their banking data. We could do it from home. So, and depending on the size, they will have a different screen. So I need to start worrying about what pieces of data that I do it, and depending on the device, I will render it differently, right? So they started breaking it down, the presentation layer, into 2 components. One is called as user interface layer, which is how user is interacting with. And second one is presentation layer of how I want to present this information. Okay, so you will start hearing there is a different design pattern called MVC, which is model view controllers, of what needs to be presented, at what time it needs to be presented, and what subset of the data needs to be presented. And this one is how I'm presenting it. So today, if I log in to my bank account from my phone, my interface is going to look different than if I'm logging in from my laptop, right? But if I'm checking the account balance, the information is still the same, but the presentation is different, right? So that's what those concepts are. Now, take for a moment, if you're a software engineer or quality assurance person. Now, this is a little complex software, right? I need to validate, hey, is this information getting pulled right on the time? Do I have the needed performance, right? Does it pull it up in a matter of seconds, or it just takes it? Think about it. How many times you ended up on a very busy day? Some sale is going on Amazon, or you're trying to access some site, and millions of people trying to hit the same thing. And how many times you get, hey, timed out, it didn't fulfill your request because it was not able to pull the data on a timely manner. Therefore, it gives you that message, right? But you need to test for all those scenarios. Well, how many customers now I can go ahead and handle it before they started having the performance issues, right? Am I presenting the same sets of information? So if you're giving me the balance information from my account, am I presenting same irrespective of this screen or that screen? Right. To a different layout, but is the data still the same? And does each of the layout shows appropriately? So those things become complicated now, but there is a need for this architecture, right? Because I have now, instead of hundreds of thousands of customers, I have millions of customers accessing my systems regularly. So I need to manage with them. Okay. Good with this architecture? Oh. All right. Then came the late 90s. Google started coming into the world. So is Netscape, AOL started coming in, where then things started coming in where I need to deal with more than one business entity. Let's take in reverse an example. Okay. Earlier, if you are a company performing some sort of sales, okay, you will, if people are physically walking in, they will have either physical credit card or they will give the cash, right? So I don't have to worry too much. I could actually see it. I can make sure the transaction and everything is valid and more. But I can see people's signature, I can validate and everything. But with the things like Amazon, okay, the complexity started to change, right? In early days, Amazon had to rely on to FedEx or UPS or United Postal Service to deliver your good, right? You ordered it, but that has to be given it, reach somewhere, right? So I need to start worrying about, hey, logistical companies are taking my item all the way to the customer, but customer wants to see where the item is since they order it, right? When it's going to arrive. So I need to start worrying about interacting with the software that's not owned by me. It's more services. Okay. Same thing with the bank. So let's take an example. Let's say you want to buy something from Amazon. Right? Let's go through it. What happens? Right. Probably item is in Amazon catalog, right? So you look for it. It says, "Hey, I want to purchase this thing." Let's say I want to purchase a specific book from that catalog. You book it, right? And then the next step is you say, "Hey, let me put it into my shopping cart." Right? So you put it in there. Now I want to check it out. That means Amazon needs to collect financial information or payment information. Okay. So when I do that payment information, well, I'm not giving cash because I'm remote. Right? Amazon has no easy way to validate my credit card. Right? So they're going to ask me to enter that information somewhere online. Okay. But that information needs to be validated. And I don't know which bank customer is going to use it, right? They could use any wide variety of banks. Or they could use either Visa, they could use MasterCard, they could use Amex, they could use Discover, right? So I don't know, somewhere the banking systems has ability to go and validate whether it's a valid credit card or not, and whether that individual, me trying to buy a book, let's say book is $100 book, do I have enough credit that I can purchase $100 item? Because potentially my card might have maxed out, right? And I should not be allowed to do any more purchases. So Amazon now has to worry about somebody else has to offer a banking service. In earlier days, in this kind of environment, I'll have a dedicated network running from my building to a bank and interact with it. But now it's over the internet. Right? So I have to rely on somebody else's service. But it's much more easier because everything is connected to this internet cloud, right? So as long as somebody offers a service that's connected to the cloud, I'll be able to go there and get that valid bank information, get that authorization, and then continue with the payments. Right? So what it generated is an ability for the different enterprises to offer the services that can be used by other entities, business entities, or individuals over the internet. So I did the payment. Then Amazon says, hey, based on the rule, I'm going to ship this thing through FedEx. Right. So now I have to figure out a way to automatically generate an invoice for FedEx, saying that, hey, I want you to ship this item through your system. Give me the tracking number so I can attach it so that my customer can view it, what it is. Or I can occasionally come to you and says, for this particular tracking number, tell me what is the status so I can display it to my customer. So FedEx has to provide a service over the internet that enables anybody to request essentially a package to be delivered, get the package tracking number, and then request the details about that package, which is going to be outside the system that they're presenting. Right? So you started seeing companies which are offering different services, like payment service, shipment service, logistical service. And companies like Amazon wanted to provide a single view to their customer about all their services. Because think about it, when you want to purchase an item, like example, if I want to purchase a book, I'm going to go ahead and interact with multiple services. Some may be provided by Amazon, some may be provided by others. But I want to have the entire transaction in one place, right? Because I don't go to Amazon, put things in a shopping cart, turn around, go to the banking website, do the payment, get the information, and then turn around to Amazon, give that payment confirmation. And then go to the shipment company, get the tracking, and go back to Amazon and just say it's done. Right? Amazon takes care of all of that. So in order to deal with that business model, the computer software evolved to something known as service-oriented architecture. So in this case, let's think about from the top to bottom. Okay. So when you go to the Amazon's website, there's a presentation of website, right? Within that, you can perform many tasks. I want to purchase an item. I want to manage my account. I want to essentially track my order, right? Or I want to return an item. There are multiple tasks you can do. So those things are known as the different activities I can do it, and each activity needs to be orchestrated. So there is an orchestration layer that comes in and says, hey, if you're purchasing it, you need to go through these steps. Versus if you're returning an item, it's 3 different steps that you need to go through. Okay. So behind the presentation layer, orchestration layer determines what will be displayed, how the user's experience is going to be different. Those orchestration layer underneath then accesses the service. So let's take an example. I want to purchase a book, right? So there is a purchase orchestration kicks in. Well, what is the first thing they do? Well, I want to look for, search for a book, right? So I might have a service which is around the product catalog that allows me to look through it, search a book, it gives you me the detail, right? Once I decide, I may do a different service, just says add this to the cart. I like this book, add to the cart. I want to go back, continue shopping it so that I can add more things. So I might have a shopping cart. I have a product catalog. I have a shopping cart. Then I may have a payment service. Once I decide to start checking it out, I need to interact with the payment service to perform the payment. Then I may need to, once I finish the payment, I may have to do the shipment service to do the shipping, right? It's all part of my single experience purchase a book, but there are multiple services underneath that. Okay. Now, beneath the service layer, I'm going to have a component which says, hey, you know what? This service can access the product catalog or product detail. Because initially when you search, you just get only a little bit detail, right? And then you click and says, hey, I want to see it. Well, also I need to worry about when somebody says add to the shipping cart, I need to say, do I have this in inventory? That means, can I ship it? Or is it in a back order? Right? If it's in a back order, I had to inform the customer, and they said, it's okay, it's a back order. I need to increase my order to the publisher and says, you know what, you're going to send me $100, send me 200 now instead of 100. Right? Because it's a back order item and then you're ordering. Underneath that, you're going to have application. Because remember, all of the inventory systems, all of the banking systems and everything, they didn't like it's when you're trying to build a new house or a new addition to the house, you don't scratch up everything, right? You keep your investment and you build on top of it. Same thing. There were billions and billions of dollars invested over the years by the companies in building the system. Just because you ended up building a new architecture to offer the customer in a different channel, that doesn't mean you throw this investment. You still need those investments you're running on top of it. So most of the banking system that has been built in mid-17s, 80s is still around. You just don't see it because you have a web layer. But underneath that, you're still accessing those core data, core systems. Okay. So that's type of service-oriented architecture. Now, from software engineer point of view, if I'm a tester, earlier I had everything within the control of my own company. All the network, all the different components were under my control. Now I need to think about scenario where that particular service may not be offered by me, but offered by somebody else. And what if that service is down? What if that service is not working? How do I manage it? How do I test that? How do I validate it? Right? Because when I take it out, a payment service, well, I have to test with multiple payment providers, right? Because MasterCard is a different gateway than the Visa is a different gateway. I need to figure it out. Hey, this payment needs to go here. When I validate it, well, are they offering it so that person's name, credit card, what else information they're asking? I need to make sure I provide all of that information versus I do it differently. Right? So my testing becomes now complex. My software quality assurance, I need to make sure that overall response they get it even with all of that thing is reasonable. If it takes 5 minutes for somebody to process the payment, how many times do you think we're going to come back to that service? Chances is 0, right? But I don't have that control, but I need to validate it. Is that true? Do we have a mechanism? Do we have structure in place? If not, should I build a dedicated line going to this bank provider so that I can build the same customer experience? Right? But there are a lot of other decisions that are going to be based on your testing. But you have to add the testing. Think about it. Monolithic versus here. Life was very simple for a software engineer and quality assurance, right? I don't have to worry about any other dependencies. Is the code right? Is the data right? Here, definitely I need to worry about is code right. So when you're taking a payment, are you taking the right payment? It's definitely a worry. But I also have to worry about what if this component is not available? What if this component is slow? What if this gets denied? How do I go process this, of course? Customers has different choice, and based on that, my complexity, the number of things I need to test is exponentially increasing. Right? My complexity and time required to validate all those paths has to be tested. Oh, now, never mind the security aspect. Right? Because now I have to validate not only you are the person who you're claiming you are, right? I can't just go pretend as a Harshal, log in the bank account and take care of the money from his account, right? The bank has to validate, I am indeed a Harshal, or I'm indeed the left before they will allow me to proceed with that thing. Right? So I have to worry about those testing, right? So there's going to be additional components which are on top of this functionality I have to worry about is security, framework, and people snoop into my data. I don't want anybody to look into my credit card number, right? Because then they can order it. So my credit card number has to be encrypted. When you test it, make sure when somebody puts it, it gets encrypted before it's sent out. Okay. So this was late 1990s, early 2000s. Then came a wonderful mobile world or mobile era. Now, my things has added additional complexity. It's not all, think about it, when I was using the laptop, most likely my laptop was connected to the internet all the time. When I'm using the phone and driving at 80 miles an hour over I-70 going west, I'm going to change from a tower to connect my phone. And there are going to be some spots, which is going to be dead spot, where my connection is going to be dropped completely. And if I'm in the middle of transaction, it needs to make sure my connectivity and transactions get saved. So that means part of things I need to start storing on my device, along with the timestamp when I last communicated. When I connect next time, I need to synchronize and says, hit me everything from the last time. Typical example, email, right? You can do it everything on your phone offline. And as soon as your phone connects it, it automatically sends those email or messages and then comes back. Right? That means in my architecture, now I have to worry about keeping a local copy, keeping when it was synced last time. And then as soon as it connects to the server, which is the main server, I have to go and ask all of that information and get it. Everything has to be encrypted. I have to handle the scenario where, hey, I was in the middle of pulling that data and things crashed, or I lost the connectivity. So it is still all the service-oriented architecture on the server side. My presentation layer is still there, but my security and connectivity has to be worried about because it's constantly connecting and reconnecting and disconnecting. Okay. Good with the architecture? Now, when you think about it from the architecture point of view, you're still going to see the system which spans across all of the architecture. And sometimes you will probably see a hybrid of things. Right? So if I'm doing a rocket system, right, and sending a mission to the Mars, they have to be self-contained. Right? They can't rely on a command because it takes like 8 minutes to reach command from Earth to Mars. By that time, if you're like it's descending it, that's why they call it terror, 10 minutes of terror, right? You have no idea till it actually landed, but did it actually landed or not? You can't adjust the velocity of when the craft is descending on Mars. So it has to be self-contained to some extent, similar mindset as monolithic architecture. But you're going to keep the data and telemetry all separate. So you have to build the components, but it's not going to communicate with you in a real time. It'll still take an 8-minute delay in terms of communication. Right. So you have to build an architecture a little bit differently of how it goes from here all the way to there, right? It's the same system. Once you've loaded the craft, it's the craft communication or management system. So you're going to see it's some combination of architecture as it evolves. But from an application point of view, you're going to end up into one of those categories when you're testing. Okay. Any questions? All right, let's take about a 5-minute break. So for those who are online, it's 10:44. Let's start back at 10:50. And if you want to stretch your leg, there is a restroom around here. There is a kitchen. I think that we have a water drink also if you like it to fill in water. Okay, no, we'll get started back at 10:50. So Weber is back.
Yeah, hi. Yes.
Hi. Can you
Yeah.
introduce yourself to the class, what you're looking at is, what's your background, and what
Yeah.
you're hoping to accomplish from the course?
Yeah. Okay. So, hi everyone. Good morning. My name is Vaibhavi Suthar, and I'm coming from Canada. I'm living right now in Brampton City of Canada, so which is located like closest to the Toronto. And I have qualified in electronics and telecommunication engineering from Canada. And I actually originated from India. So I studied electronics engineering from there as well. And I did post-graduation from Canada. I was working as an electronics technician in a different companies from Canada. And then I also lived in Australia for a couple of years. So I just came back from Australia in December 2020 and I migrated here. So I work in Australia as well as an electronics technician. And right now I'm working as an inside sales representative in Dell Computers. So basically I joined this course because I just wanted to add some skills to my field, and I just wanted to go with the software side a little bit because I know electronics is like most probably is hardware and software, but this is something will add up in my career and I can just progress a little bit. So it's like, let's see how my experience will be with this course, and then let's see how it helps. Yep.
Thank you, Vaibhavi.
Sorry, may I know your name, please? I know Harshal actually, but I'm just see you first time. So
Yeah, so Vaibhavi,
yeah.
I'm Philip Patel. I've been teaching this course with Harshal for over 7+ years. In fact, Harshal and I built it together. And prior to that, I had a lot more experience as an adjunct faculty to the local university, as well as I taught at Wright State University also in late 90s, early 2000.
Oh, okay.
And as a day profession, I'm working in JP Morgan Chase, which is a banking organization, but I'm on the technology side, working more on the various transformation and transformative programs. So one of the things that I worked at late in the last 3 years is transforming how they build the software and transforming the engineering practices. Most of the business bank, not business, commercial business banking uses that. And right now I'm kind of focused on transforming it in a more product-oriented organization at the JP Morgan.
Okay, nice to meet you.
So now,
thank you.
Sure. Now let's pick up, right? So far we talked about the architecture. Now let's look a little bit into from a different lens in terms of how the software is built. Oh, that's, I wrote it down on paper. No. Let's look at it from a different angle in terms of what is the life cycle of a software development. Okay. So let's talk before that. If you have to build a home, right, what is the normal life cycle you will go through it in building a home? Okay. So let's say if I want to build a home, right, the first thing I'm going to determine is, do I even have a need to build a home, right? Or can I live in a rental apartment? So there's going to be some sort of a decision because there's going to be financial aspect involved into those decisions, right? So there will be a decision process that I'll go through it before making a decision. I really want to build a home. Right? So you go through that process, and essentially it's a analysis process where you identify whether you want to go. If I do want to move forward, let's say building in my own home, what is the next logical step? I'm going to go look for it and say, okay, what actually am I looking into that home? Am I looking to live in a downtown? Am I looking to live in a suburb? Am I looking into townhome type of structure, or am I looking to build it into freestanding single home structure? And I have to look for it in terms of, well, how big the home I want, how many bedrooms I want it, what kind of structure I want it. Do I want a ranch home? Do I want a multi-story? What exactly I want it? Do I want a patio? What kind of things I want it? So, because every decision also has a financial impact with it. Also, it has a restriction in terms of which location I can go, what school systems I'll go into, right? So, once I make a decision if I want to build a home, I need to do a second set of it. What type of home I want it and where I want it. Once I do that, like, hey, I want this type of home, I want this structure and so on. The next step is finding a architecture company or a contractor, right, who will build an architecture on a paper based on your requirement, based on those things that you wanted. Here is what you need to build. Here is what it will look like. Here's how many frame you need it. Here is how big the plot you need it. Here is how big the construction area will be, and so on, right? And obviously, as I go through it, I have to go to the county, get in the necessary approval for that structure before I start building that structure, right? So I will design my home first, working with an architect or working with a builder. Then I will go into the construction, right? I'll hire somebody, or maybe I hire the same builder who did the architecture to build the house. So they will go and build the house. And as they build the house, county will start validating, is the plumbing system right? Is the electrical system right? Right. So there will be some testing involved as the house comes up. What typically company calls it is inspections, right? There's various sets of inspection which will come as I build the house. And then once the house is built, obviously, I'm not just going to walk in, right? I'm going to go through it, test it, make sure it's the electrical working. Right? I'll make sure the air system is working, AC is working, flush is working. The house is built according to the design that I did it. If I just say, hey, build me a multi-story house and build a ranch home, obviously I don't want to pay that, right? Because they didn't build what I wanted it, or they didn't build according to the specification or architecture that was put together. So I'll perform those testing. And at some point, I would say, yes, it's built according to what I wanted it, built according to specs, right? So I said, okay, fine, then it's done. Let's go to the closing. The builder gets its own money, right? I get into buying it or taking a loan from the bank. All of that thing is completed. Now I move into the house. Now the maintenance base kicks in, right? Hey, I want to build a patio. I want to build a deck. Right? I can do whatever the extension now I want it, and that is part of the maintenance, or maybe a small subset of project. I'm trying to do that. Right? That's the life cycle of a house. Right? Similarly, there is a life cycle of software. So if you look into it, same way, the software starts from a plan. Somebody had to make a decision that, hey, we need to build a software to do this particular task. They have to make a due diligence. Does it make sense? Is there a need? Are we going to make a money if we build that software? Right? So let's say Amazon wants to build a specific inventory system. Right? They're going to first make a decision. Do we need it? If the answer after all those decisions comes out, yes, we need an inventory system. So it can track it where those information, where all the materials are in which warehouse. So when the customer orders it, we can identify the closest location and start shipping it from there. Great. Now there is a need for inventory system. So let's look at it. What should that inventory system contain? What function should be? What features, what capabilities should be? Let's lay it out so everybody knows it, that this is what we're going to build it. Then the next phase comes is design. Well, if I need all these things, well, what should be the structure? Do I need a monolithic architecture? Do I need a high-end completely mobile architecture? Because everything comes with the trade-offs, cost associated with it. Right? If I needed only to manage 15 warehouses and inventory, I'm not going to build it that in future manages thousands and thousands of warehouses. Right? Versus, hey, I want to build an inventory system that not only allows people to look at what's in our warehouse, but I have all this third-party sellers. I want to see what's in their warehouse. Now it's a different architecture. Now it's a different scenario that I need to build it. Right? So based on analysis, I'll build a design. So this tells me what features I need to build it to it. This is how I'm going to build it. Then I'm going to get into the implementation. Now that I've settled down on the architecture, what component needs to it, let me build all those components. And as I build it, I'm going to test it in a cycle, right? Build it, test it, didn't work, let me go fix it. This whole cycle till I'm happy with that. Once I'm happy with that inventory system, I'm going to present it to the stakeholder and say, here it is. Right? They're going to validate, make sure it fulfills it, make sure it works it as expected. You're going to accept it and make it an operational, right? So now every warehouse needs to start using this system to manage their inventory. And then I go into the maintenance phase. So if you look into it, right, the software essentially follows the similar architecture in our life cycle. Okay. So this whole term you will hear a lot of times as an Sdlc, also known as software development lifecycle. Okay. Now, another angle of it, as you're developing, if I want to build a house, that's it. And if I go to 4 different builders, do you think they will follow exact same process? Most likely not, right? Everybody's going to use it. What is more adjust and fine tune to them. Same way, the software development also, the whole implementation cycle of Sdlc, of how people go and build it, it also depends on what your organizational processes are, and also depends on some factors in the market, right? Is what is the need of the market, how often I want it, how do I manage my finances, and so on. So depending on that, there are 3 dominant software development methodologies. Okay. The one is known as a waterfall. The other one is known as a rational unified or RUP process. And the third one is Agile. Okay. Let's look at each one of them. So the first overall process or development methodology you're going to see it is Agile Development methodology. In this scenario, you essentially have a vision that this is what I want the software to do, that function. And then you build it into small increments towards that particular vision. But the way you build it is that every small increment is going to be useful to your customer, or you can sell that small piece and start making a money. Okay. Let's take an example. We talked about the text software as one of the things that most commonly do. Right? So when you go and buy a text software, right? Typically there is a multiple components in it, right? There is a federal tax that you pay. There is a state tax that you pay. And then there is a local or city tax that you pay, right? So there are 3 components. Ideally, you want to have a software that allows you to do everything, and all things. Now, within the federal, you have various categories. You can just have a 1040 easy, which is the simplest version. You can have a 1040 single, where you can say, I want to have a joint filing, or I want to have an itemized. Or I want to have a business also, right? So there are various views and various complexities. Now just imagine, if you are to build the text software from ground up with all those features, it's probably going to take many years to build it, right? Because For the state, you have to do 50 states. And then each one of the state has a whole bunch of different localities, and each locality has their own tax rules, right? And there are certain aspects of federal taxing that impacts the state tax, which impacts the other one. So building a tax software is a complicated, and it may take a lot of time. Now, you don't want to be in a scenario. If you say, hey, I'm going to wait, I want to build everything, and then start selling your customer. Guess what? Every year, Congress adds additional laws, changes the taxes. So I have to keep changing it regularly. So I may have to change it 4 or 5 times before actually I ever sell it to any customer. Now think about it, the amount of the money that I have to put it into it for that many years. Right. On top of that, every time Congress changes the law, even if I build a certain components, I have to go back and change it and modify it. And I have to figure it out what all that impacts. So building that is a complex thing. Most of the company, right? Either you need to have very deep pockets or a lot of finances to build it, or you take another approach. You know what? I know things are going to change. What if I build it such a way that I build one small thing at a time and try to sell my customers? So the risk is I don't have to keep investing a lot of money before I get anything back. The second thing is as things change, or if I decided that my business model and market is changing and I want to stop the project, my money is not completely wasted. Right? So you can think about it. I have a vision to build a tax software. I can say that my first iteration, the first version of software I'm going to build it is only those people who need to file a federal tax return and who are filing only 1040Es. Right? Now that's probably only 1% of the total population which files that. But now I can sell that to that 1%, start getting some money back. While I build, okay, I'm going to go from a simple to I'm going to go to itemized. Well, I already have this component, so I'm building on top of it. Then I can say I'm going to build it where somebody can file jointly with the dependents on it. Well, I'm increasing from 1% of customer base to 2% to 10% and so on. But every time I'm releasing it, I can sell it to more and more people and start recovering some of my money. Right. Now, within each cycle, I'm going to follow the same Sdlc, right? So if I'm going to do a simple tax return, well, I still need to know what is the requirements are. I need to analyze, I need to build a design, I need to implement, I need to test it, and I need to deploy it. I still have to go through that entire life cycle in every phase. Okay. So now think about this is at a high level, it's big. But I may have to do this duration and release a lot more quickly. Right, so I may just release it every 2 weeks typically. I'll try to build a new version of software every 2 weeks and start putting it out in the market. So if you think about all of you use Facebook, Microsoft, right? How often things on a Facebook change? WhatsApp. Guess how often it changes? Once a month, once a week, once a day, every day. What if I tell you they change it every 30 minutes across the globe? They just do it the whole release and then just start cascading across the globe. They do the release every release. But they have groups which are dedicated, which focuses on 2 weeks of development, and then they just release it. Small development rules. Right? A lot of companies are moving to this direction. Mainly because things are changing, because your markets are constantly adapting. If you don't offer that capability, if you waited, think of this, right? The millennials, they don't go to the bank. They want to do everything online. Right? if you are a traditional bank and says, hey, I'm going to take a 4-year to offer a way for you to do an online banking. Because how many customers are going to stick to you? If there is another banker who says, hey, I can start offering you, just check your balance online first. Don't have to be full-fledged bank, but the perception is I'm already offering online banking. And then you can add the features over the period. And if certain features customer doesn't like, it's great. You can get rid of them. You don't have to build a whole online bank. And that determines what your customers are liking and what not liking. Right? So that concept is what is kind of getting most prevalent. Majority of organizations are shifting with this, mainly because the customer segment and market has changed from a company-driven culture to a customer-driven culture. If you go back, the way I kind of tell leadership in chases, you think about it, in 1980s, you as a bank will define a product and tell the customer, this is the product and you will use it. Right? Now, fast forward to now. Your customer tells what they want from a bank. And you build a product according to what they wanted, not what you think they needed. They're going to tell what they needed and whether you can fulfill it. Right? So that's the change of culture from company-driven to a customer-driven products. Any question on Agile before I move on? It's a small increment, you deploy it, but it's a continuous work. The second methodology, it came out from IBM's what is known as a rational unified process or a RUP process. Okay, this is an iterative. So think of it. The Facebook doing an patch every 30 minutes going across the world, it's great. But if I'm building a system to send people to Mars, right, I can't operate in the same way as I did in Agile. You had to build it into pieces. You have to validate it and move it and then construct it. Right? You can't change your rocket once it's launched. You can't change it till it reaches to Mars. Right? So you have to build it into pieces. So think about it. That's the rough process. It's usually designed for the large project where you have multiple pieces. And then you think about it. So it's not very nimble or agile, but it allows you to build it incrementally. Right? So think about it. They have 4 phases called inception, elaboration, construction, and transition. If you look at this angle, it's more or less like similar to Sdlc, right? I do requirements, business modeling, requirements, do an analysis, implementation, test, and deploy. Right? And then there is a maintenance, which is managing the environment, configuration, and so on. In this concept, right, you start at the inception level, you start figuring it out. Hey, what all pieces I need? Can I do model it? Right? So as NASA is building a system to send the humans to Mars, right, they're building different models and pieces. Right? They're building a model around, hey, what will the habitation look like for the people once they reach to Mars? What will it look like while they're in transit from here to Mars? And what will it look like to launch system from here to Mars? What will it look like? How are you going to get the people back? So that means, yeah, you have a huge infrastructure here. There's nothing on the Mars. How are we going to launch people into the orbit from there? How are we going to do it? How are we going to validate all of those models? Well, that's not only like sending it, right? It's checking the health system, tracking their transportation, right? Because there is no Google map from here to Mars. But hey, you're in the wrong path. You're 3 degrees off. Well, how are we going to do that? Right? So you have to do a whole bunch of business modeling. You start identifying those requirements. That's what typically an inception phase. It's a heavy on modeling. Same thing, if I'm building a software, right? What all component I needed, can I model each one of them, right? I want to build a fully autonomous vehicle. Well, what all things I need to worry about? Well, I need to worry about traffic. I need to worry about the telemetry within the vehicle. I need to worry about what the roadmap direction look like it, right? So that I can navigate it. Because human does that naturally. But when you're building an autonomous vehicle, you need to start thinking about all of this. So you have to model all of that. And then you elaborate. You say, okay, yeah, I need a traffic navigation system. Well, that's fine. Let's look at it, how I'm going to map, what I'm going to do that. And there may be multiple things that I need to iterate. Yeah, build it this way, let me test it, works it, let me enhance it. So there's going to be more requirements and more analysis, little less modeling in this particular phase, where I'm elaborating exactly the detailing it out, what I needed, how I want it, and how it's going to interact. Then I entered the third phase, which is the construction. Okay, where I'm going to start building with, okay, let me just build one system. So if you look into it, what NASA is doing in order to send it to the humans, to Mars, is let's just figure it out, get a reliable system to go from here to low Earth orbits. Once it works, let me put the second phase, which will take them to the moon. And they'll live on the moon for an extended period of time without worrying about it. Because the moon is a lot more closer, right? People can get back and forth in 3 days. But once you go to the Mars, it's 6 months. You can't just simply turn around and come back. Right? So I may have to do a whole bunch of construction, but each system is validated, tested into a real production-like environment. It's not complete yet, but each one of them is there. So I may build multiple phases. Same thing for the software, autonomous vehicle. I may just build it. Can it go into a closed track by itself? Great. Now can I put into a light traffic? Can I put in the heavy traffic? Right? Can I put it so that it constantly adapts based on traffic? It changes the path on which it goes. So each component, right, they're going to do it separately. And then once the whole thing is built, then you do a transition, you start doing a deployment, right? So once NASA has figured out all the systems, they're going to send the people to the Mars. Right? So it's still, if you think about it, right? You're still building into pieces, just like what we did in Agile. However, the difference is in Agile, after every iteration, you're putting into production, making it live. Here, you're building each pieces. You're testing individually each pieces, probably putting into production each individual pieces to validate, but your system is not effective or not operable till everything is done. Okay, so that's the difference. So this is typically used into a large project, right? So when they build a new aircraft, right? So when they build an F-35 or F-16, they have to build a whole bunch of systems, right? Right from support system to navigation system to missile firing system to defense systems. All those things essentially does it. So that's when this kind of methodology is typically used. Earlier, a lot of companies used to do this. This is typically when you're doing a project that lasts a couple of years before you can start realizing any value. Okay, good so far?
I got a question. So when they get into the business, so they start business and they got the alignment and the design. So like, if it's something they want to change something and then they already building the business, how they?
So they will still do it. So if you look at it, right, at every phase, there is still some feedback going. They're making changes, and that's why you have multiple iterations in that, right? I built it the first system to put the humans on moon. I learned from it. I need to adapt it and adjust it. Let me get the second version of it. Let me do it, and then third version. Now, this is according to everything that I wanted. If I fine-tuned it, now it's ready to send it to the Mars. Because I can't do a change quickly on Mars. Right? Because it takes 6 months to go there, 6 months to come back. So anything I need to do it, I need to do it with a mind that nothing can be changed in flight for a year. It has to be self-sufficient. Versus Moon, I can do it, I can abandon. If I've just gone into low Earth orbit, things didn't work out fine. You just land back on Earth. Can do that in the Mars. Okay. So that's the iteration. And the third method is waterfall. So think about it, waterfall, right? In waterfall, the water always moves from the top to bottom, right? If you take something halfway and put it at the top, it's not going to jump directly to the end. It'll fall back the same way, okay? So in a Sdlc cycle, right? You start with requirement analysis, go all the way to the construction. So think of that. If you do a requirement analysis, in a waterfall world, the mindset is, I need to finish everything that I'm analyzing it first before I go into the design piece. I need to design everything before I go write a single piece of one. Okay, so this is a scenario where, hey, I'm building a tax system. Let me get all the state laws, all the federal laws, all the local laws. Get all of that understood very well first before I go and design it. Okay. You need to do entire design. And if I find out some problem or missing data on the design, I'm going to go back to the requirement analysis. I'm going to restart it from there. Once I'm done with the design, I'm going to start writing the code. Oh, guess what? It's almost a year since we did the requirement analysis. Congress changed the law. Well, I'm going to go back to start. I'm going to understand what the changes of impact is going to be before I continue back. Well, that changes may require me to update my design, may require to change the code. Right? So here, I almost try to finish everything in the previous state before I start work on the current state. And anytime any changes happen, I have to go back at the top and redo it. So that's the waterfall. Typically, right? So take the same example of tech software. If it was going to take combined 3 years to build it, in an agile world, it didn't take any faster. All it just says you change the perception of what the value you are adding in each phase. Here, you're trying to get the whole piece. And guess what? 3 years into it, you decide that, hey, the way that the government charges people, the tax system is completely changed, or we don't think we can make that much money because of the market factors and need to scrap the project. And you spend $50 million till that point, but the entire $50 million goes to waste. Didn't recover a single penny, didn't deliver anything of any value to any customer or to business, and you just wasted your $50 million. Now, while saying that, most of the companies till early 2000 were just using this. That's why everything was taking forever to build it and deploy. Okay. There was a saying that anything that you ask IT to build it, it takes $10 million and takes 4 years. Right? That was the mindset. Hey, you want me because I don't know everything? I'm going to put it in all the factors. But what if you change this requirement? I need to redo it again. It's going to take me this much time. So that's what everybody was adding. Speaking of that, you will see it. Companies started moving it away from waterfall, going into the agile world because of the value that it adds. However, not many companies pure agile or pure waterfall. You can find it. A lot of companies are still in the transition mindset where they try to do it, but then they keep doing the work, but they don't deploy it in production once every 6 months. So that's a hybrid versus if you're doing true agile, you go into production at the end of every cycle. Any questions on this one? Okay. So now so we talked about the software, we talked about how it's been built. Now let's talk about why it's important from a quality assurance point of view. Now you will hear throughout me talking about distinction between the testing and a quality assurance. Okay, it's two different things. Like when people talk about testing, they talk about a very small subset of quality assurance work. So think of this way. If I'm building a home and I'm going to solely rely on testing, that means I have to wait till they're done building the whole thing and then I'm going to test it. Right? Let's say if they build the electrical system, right? After the whole house, I go in and develop or build, I go in and try to test it. The light doesn't turn on. Well, what do they have to do? They have to rip all the drywall to figure it out where the disconnect is, where the problem is. Right? And all at that point I did it is just to tell you that things doesn't work. I didn't do anything which says that, hey, when it's done building it, is it going to work or not? Right? So if I would have focused on all along the construction that every piece is working as I'm building it, and is it working as expected? That would have been quality assurance, right? I helped it in producing quality work at the end. Now, I may have to make sure that I get the certified people to do that. That's part of quality assurance, right? Versus, hey, I've read on the internet how to wire your home. Let me go and do that. Right? I may not know all the codes. I may not know all the set. Right? I may not know all the load that you need to do it, right? I needed it like 10-watt circuit, and I put it only 5. All things is going to trip right and left once I connect the equipment. Right? So same thing with the software. Like if you focus just only on testing, it just tells you that, hey, did you build it according to what specifications? But it doesn't allow you to say, is my specification complete? Am I missing something? Right. The process where I kind of get engaged right from the start to make sure, is this thing what I'm building is of value? Is it quality? Then that's a software quality issue. To me, it covers the entire life cycle and not just the test phase, versus testing is just the test phase. Okay. So again, quality has to be built as part of the software, just like we talked about the house, and not an afterthought. Because by the time you just test it, it's too late. Things is already built. If you change anything, now you're going to add the time, you're going to add the money, and potentially a opportunity cost. I'm building a software to serve a certain segment of customer. There's another competitor also trying to do the same thing. If I build a poor quality, it doesn't meet the need, versus the other guy builds a good quality, comes 1 week later than me, guess what? What's going to happen? While I'm going to try to refix it, he's going to take all my customer and then they may not come back. So that's in a nutshell is where the value of the quality comes from. Okay. Now let's start looking into the Sdlc. Okay, so let's start getting into actual software development process. Okay, so if you look into it in Sdlc, right, what was the first thing? Is this planning? Right. What is planning? Planning is nothing but to identify, do I need to build a software? And if I build that software, what problem it's solving, how it is helping me, and is it worth building? Right? So that's the aspect. So when you look into planning, Okay. You try to identify how this is going to help my business. Because nobody's going to give you free money to just say, hey, go build a software. We'll figure out what problem we're going to solve it later. Right? Business doesn't work that way. Business needs to make money. So if somebody is giving you money to build a software, right, they have a proposition which says that if I build a software, I'm going to get it. Right? Nobody's going to give you free for anything. Right? So that's going to be a value. So if I'm a business, there are various sets of business problems, right? And if you look into overall business problems, it falls into one of the 5 categories. Okay. So let me walk you through an example before we get into this. Think of a scenario. Okay. I'm a small mom and pop bookstore. Okay. I have 3 locations in the city and a 1 warehouse. Just think about that scenario. It's a small business. They want to do it. Okay. And people come to my store to buy a book. That's primary business. That's what my whole area is. Now, let's say I want to address one aspect of the business, which is somebody comes in and asks me, do I have book XYZ or not? Okay, that's simple thing that I'm trying to address customers for. So the logical way it is, I'm going to look into my bookstore, see if I have that book or not. Let's say I don't have any computer system, right? I'm going to actually go across the whole bookshelf and see if I have a book or not. Let's say I don't have it in the first store. I'm going to, instead of sending customer back, right, I can just say, let me pick up a phone, call the other location, says, can you find out if you have this book? Right? They look through their store. He says, no, we don't have it. Then I call the third store. Same process. Then if they don't have it, let me call their warehouse. Do they have it or not? If they don't have it, I tell customer, okay, you need to back order, and it'll take business days. Now, think about the process. Okay. As a process, I went through sequentially 4 different stores, 4 different locations, right? 3 bookstores and a warehouse, to go manually check it whether I have this book or not. Right? So my process of finding whether I have a book or not is that long. Now I can just say, hey, you know what? I'm going to do an improvement in this process. Instead of asking sequentially, as soon as the customer comes, let me pick up a phone and call other 3 locations and says, hey, customer wants to see this book. Why don't you go and look for it if the book is available? Okay. So now I improve a process. Instead of sequential, I made it parallel. Right? No computer, nothing. But by doing that, right, let's say it took 1 employee 4 hours to find a book. Go through the entire store and say it's whether I have a book or not. Did it improve any productivity? Probably not, right? It still took 4 hours for each employee to do it. So when I look at it from the business point of view, it still took 16 hours to figure it out, whether, right? So I still need somebody's 16 hours time to determine whether the book is there or not. Now, what if I say, hey, you know what? I don't want to spend 16 hours to find a book, whether I need it or not. Can we cut down that to, let's say, 8 hours? I said, sure. Why don't we order the book in alphabetically? Right? So when a customer wants it, based on the name that they give it of the book or the author, I can quickly go and look only in that section to see if they have it or not. That way I can cut down the amount of time it's needed. So in order to do that, first I need to make sure my books are arranged alphabetically. Right. But once it's done, my productivity is going to be improved significantly. With me so far? It's the same thing that customer is trying to do it, but if I have an angle of whether it's a right process versus, hey, is it more effective for me in terms of productivity? So I have only 2 employees. How many books they can find it? How many customers they can serve it, right? Now I increase their productivity, still with the 2 employees. The third thing could be a cycle time improvement. Right? So if I say it, hey, productivity is great, but it takes 16 hours to find a book. And that's a cycle time, that from the time the request came till time they got the answer is 16 hours. What if I want to reduce that down? Right? And the way I can do that is by making it sure that they're not only alphabetically ordered, but they also have a chart which they can quickly locate it based on number of books available or not. They can quickly locate through that instead of physically going into the bookstores and every shelf. They can quickly scan this thing and tell the answer yes or no. And instead of 16 hours, it's taking them 1 hour to go through it. Right? So now I can get the answer much more faster because the cycle time is no longer 16 hours, it's came 1 hour, with the hope that if the customer doesn't have to wait for 16 hours to find it, if they're found within 1 hour, they will most likely purchase from me instead of purchasing from the company. Right? Good so far? If I had to focus on that, that's a cycle time improvement. But let's say, what if I change the mindset and say, it takes 16 hours to find a book, and I'm paying employee $10 an hour. So just to answer that one question, I'm spending $160. Right. What if I want to spend only $5? Right. That means somebody should be able to find that answer within 30 minutes. My goal is, I don't care how you find it in 30 minutes, but I want to spend only 30 minutes in this one because I want to bring my cost down from 160 to $5. Now let's go look at it. What are the options I have available to bring it down into 30 minutes? If you go with that mindset, and that's primary goal for the business, then I'm focusing on reducing the cost. Right? And one way could be, hey, let's not make the phone call. Let's connect all these 3 stores into a single inventory system and then have people scan it. That could work too. And then finally, what if I want to improve a market share? That means so far somebody has to actually come to my store, one of the stores, to look into that. But what if I can just say, hey, you can either come to my store or you can call our store. Here's the 800 number, and we can answer it. Chances that now, not only the people who are within the city, the people who are outside the city can call it and find out whether I have to book or not, right? So my market, which was just consigned to the number of people living in the city, now get that expanded to whoever can call me. Right, so I'm increasing my market share. Good so far? So depending on how you want to solve the problem, you're going to end up and says, hey, what is my primary driver? Now, you may run in a scenario where, hey, I need to reduce the cost. Right? Well, it's great. But by implementing the solution to reduce the cost, you also help improving cycle time in increased productivity. It's great. But those were not my primary driver, right? Those are additional benefits or additional value that I got. But my primary driver was to reduce the cost, right? So any business problem that you're going to look into building a software, it's going to be driven by one of these 5 factors, right? And then you need to first figure out what is that factor? What is the primary factor? Now, I may have other beneficial factors. But when you look into the business analysis, when you make a decision, you usually look into one of those factors and make a decision. Okay. So let's do a quick exercise. Right? I'm going to give you guys 5 minutes to read a problem. Now, for those who have a folder with you, if you flip to the second tab, can I borrow a folder? Let me show you guys what you have in the folder, right? So the first section is all the slides that we are going through it. If you go into the second segment, okay, you have all the exercises you can do. Okay, it's about only a couple of pages. Then the next segment is a set of documents. Okay, and we'll talk about the document before we end the day today. Okay, and then the last segment, you have some additional information. Okay, so what I want you guys to do is go into the second segment, which says exercises. Okay, and for those who are online, first I'll send you a document which has all, there is a PDF in it. And it'll look like this. Okay, can you guys see my screen? Online? Whether or anybody else can see the screen?
Yes, I can see.
Okay. So this is the business problem. What I want you to do is spend 5 minutes to read through the problem. It's only exercise 1 for those who are looking at the paper copy. And I want you to read through it and figure it out first yourself. If this is the business problem, which is the primary driver out of the 5 that we talked about? Okay. So is that business problem talking about the need for process improvement? Is it talking about the need for productivity improvement? Is it talking about cycle time, cost reduction, or market share improvement? Okay, so read through it, figure out which one it is. Okay. Yeah, so I'm going to give you 5 minutes. It's 11:45. Take time till 11:50 to read through it.
If online everybody has the
Yes.
whole
It's-
product.
I guess ready? In a couple of more minutes. Good. Who is still reading through it? Still need some more time. Online, are you guys ready?
I couldn't read it. It's not clear.
Okay. So hang on. We'll talk through questions. What questions you have? This is Leela. Leela, what question you have? If you said that it was not clear, tell me what questions you have.
Whole thing, I couldn't read it.
Oh,
It's not, oh yeah, I couldn't read the whole page.
You need a couple of, well, it's online, like it's Harshal will send you a PDF.
I already sent them in the email. Everybody please check your email.
Read through your email. The document is already there, so you should be able to read through it. Yeah, don't try to read it on the video screen.
Read in the email. Thank you. Thank you.
Yeah, so take a couple of minutes, read through it.
Did you share this screen? This part because they are still seeing the business problem identification.
Oh, they're not seeing this?
Yeah,
Okay.
what you shared.
Okay.
But you didn't share the desktop.
You see it now?
Now it's now.
Okay. Well, they're reading it online. Let's talk about it here in the class. Okay. What I want you to do is tell me in your mind which of the problem it's solving. So if somebody gives you this description, okay. So just with the raise of hand, tell me how many of you think that this is a need for process improvement? 2. Okay, and then that's the primary reason, right? Okay. How many of you think it's a productivity improvement? And nobody here. No, I'll come back to the online guys in a minute. How many of you think it's a cycle time improvement? 2 or 3 of you. All right. That means none of you think it's a cost improvement or market share improvement. All right. Online. What do you guys think based on your reading so far? So Leela, what do you think? Which one of the problem it is? Is it process improvement or productivity improvement or cycle time, cost, or market share?
Process improvement.
Okay. What about you, Vaibhavi?
I would say cycle time improvement,
Okay.
and also the cost.
No, which one is the primary?
Cycle time.
Okay. And what about you, Holly?
Cycle time.
So you also think it's cycle time?
Cycle time.
All right. Okay. So here's what we're going to do. Right? 2 of you say that it's a process improvement, and so is Leela online says that process improvement. So can you tell me what you read in this thing, which made you believe that it's a process improvement?
Okay, the reason is why I chose process improvement, because the first time I thought it was cycle time improvement. But when I looked at the process, the first line, it says, Athlon.com is a company that will be financing auto repairs. Currently, there's no single customer product that exists that allows tracking dealer financing for auto repairs.
Mhm.
and then I'll do repair workflow. So that confusing me again.
Okay. So you think that first line is the reason why you think this one, right?
The process.
Managing the workflow is the reason why you think it's a process improvement.
The system is not there.
Okay. All right.
So, yeah.
What about you?
They have already mentioned that the implement are doing it, like, will get the process down from several days to within a week. So I didn't think of cycle time, but when I read the process of the steps A, B, C, the process which they are going through is like a lengthy process. So I thought the process there needs an improvement and the time.
Okay.
Which is interrelated to time as well. If they improve the process, the time also can be improved.
So this is the side effect. This is the primary reason.
Yeah.
Okay. All right. What about you online?
Yeah, for me, the same thing, like the process A, B, and C, like when I read that, I thought the process time can be improved.
Now, other 5 team members said it's a cycle time improvement. Anyone you want to share their thoughts? Why did they think? You heard the 3 team members who said process improvement. Why do you think it's a cycle time improvement? Who wants to say it?
For me, when I read the first part, they said they have like a new developed like a commercial system. I mean, it may help them to find the products very easily.
Mm-hmm.
So when I look at the way when the customer show up in the shop and then the associate look at the log in the computer, I mean, the way was very fast to help the customer. That's why I say the cycle of time improvement to get no contact with it after that.
Okay.
So right here, it's just a complication. They want to reduce the loan approval.
So you want to say this one, right? Okay. Good.
Yeah, the same is with me, because at the end of the first paragraph, it says ultimately reduce the loan approval time by the lenders. So ultimately, they want to reduce the time. So for that, they have like set up some portfolio, like how they're going to do the process, but their aim was to reduce the time.
Okay. How about you guys online?
Yeah, so I would say the same as like in the first paragraph, it says reduce the loan approval time. And if you see in the points, like point G, it says that a lender would then approve or deny the credit application. So I think that the time makes big difference for approval and denying. Yeah.
Right. Any other view? All right. So for process improvement, which process they have improved?
To decide if they're going to get the loan for the.
So realize, in order to improve a process, I need to have a process that currently I'm executing it. And then I'm going to do some changes so that the process is improved. Like, what is my current process?
The manual, I think it's manual process.
Okay, so let me ask it the question the other way. When you say it's a manual process, what is the name? What is the task of the process? That getting a loan?
Yeah.
Okay. What is my current process to get a loan? If I'm an ARF loan, what is my current process to give a loan? Do I have a process? If I don't have a process, what am I improving? Can I improve something that I don't have? Okay. So I can improve something that I don't have. Let's talk about cycle time improvement. What is the current cycle time? 1 week, 2 weeks, 5 weeks, 10 weeks? And cycle time for doing what?
You can have your product easy.
So think of it. Okay. Who is funding this business problem? Who is trying to solve things? Who's your stakeholder here?
It's the Afron company.
Okay.
Yeah.
Are we all on the same page? It's our phone?
Yeah.
Okay. So what is the cycle time our phone has today to give the loan that you are trying to improve?
Say connection several days.
Does our phone finance today? Let's read this thing.
This sentence is very confusing. Currently, there is not a single commercial product existing.
Okay, so what does that tell you?
They don't have the market share.
So there is no product. If there is no product, do I have a cycle time to sell a product? Can I sell against something that doesn't exist?
Yeah.
Right? Can I do a cycle time improvement of something that doesn't exist? Yes? No? Yes, right?
Yeah.
So what do I do? Market share. Why do you think it's market share?
Okay, now after you cost actually.
Again, I'm just saying that in my mind, I'm not saying you that this is right or wrong.
Okay.
I'm saying it's based on the answers you are giving me. I'm not convinced it's a process improvement or cycle time improvement. Unless you put an argument that tells me, no, that you're mistaken, this is what the process is, here is what I'm trying to improve. We just talked, there is no process. If there is no process, there is no cycle time. So what I'm improving? Now you're saying is that after reading it again, you think it's a market share. Tell me why you think it's a market share.
Okay, so based on the second paragraph where they will have the system vendor that will have independent contractors that will sign up. And when you come now to the list, that will make customers, it will be more valuable and many people actually will.
Let me ask you, what is my current market share? And what I'm improving to?
We don't have a name, so we are still not sure the market share at all. Since we're not in the process at all.
So if I'm not in a process, what is my current share? Nothing, right? So my current share is 0%. Okay. What about the productivity improvement?
There's no process going on, so there'll be no productivity.
Remember, the productivity is not tied to the process. Productivity is tied to people. Right? Productivity is not about, do I have an efficient process, right? Productivity is, can my people do it more effectively? Are they more productive or not? Okay. You think it's productivity? What about cost reduction?
They are trying to reduce the cost because they also say that they are trying to reduce the approval time from the several days to.
Okay, what is my current cost? If I don't know my current costs, what I'm trying to reduce.
I think the better one, you need to have the productivity improvement, because we have a customer who show up in the store and then that means he's looking some product.
Let me ask another question, and this is for both online as well as in classroom here. Can anybody explain what is the business they're trying to do?
They're trying to get a loan.
Loan for what?
Financing auto repair.
Auto repairs.
How, give me a scenario, walk me through it, what is the problem? What exactly are they trying to do? Okay, so think of this way. I have a certain problem with my auto, right? It's not working. I go to auto repair shop or a dealer, right? And tell them, hey, I need this fix because I need to go to work. They come back and says it's going to cost you this much money. Right? And I say, I don't have that much money. What am I going to do? It's not an accident. It's a maintenance problem. Insurance doesn't pay for maintenance.
Yeah.
If they do, let me know which one. I will sign it for that.
Not for the maintenance. Yeah.
All right. So the maintenance here to come from your pocket. I don't have the money. So what are my choices? Borrow money, right? Where do I borrow money from? If I go to bank will give me a loan for buying a new car. They don't give me a loan for fixing the car. Have you seen it? What are my choices? So what this thing is trying to tell it is that, hey, if you don't have money, right? As a dealer, you can just say, hey, you know what? Great, you don't have money. Let me connect you with a lender based on your current profile. If they are willing to give the money to me, I'll fix the car, and then you pay the loan amount to that lender. Right? So instead of going to the bank and giving you a loan which will be financed by somebody else, but it will be solely for fixing the car. It's not for you to get the money and go wherever you want. Because if they give you the money, you can potentially go somewhere else and fix your car. There is no benefit from it. Right? But if I help you get the loan, but they don't do the payment to you, they give it to me. I get the money to fix the car, I get the business. You pay the loan to those guys. That's the model that they're talking about. Okay. So now that you know the model, now that you read it, all of you read it, let's do one more round of voting. What do you think the key problem they're trying to solve is? Is it process improvement? Let's go one at a time.
I would still stick with that.
You will still stick with process improvement. What is the process improvement? I want you to think about it, right? Hang on to your answer. Let's go through it. You still think it's a process improvement, right? So I'm going to change the round two numbers. One. Anybody online thinks it's still process improvement? Silence is golden. Productivity improvement. You think it's productivity improvement? All right. Anybody online?
Sorry, can you say question again, please?
Now that you had an opportunity to hear everybody's view, and we talked and we explained the business scenario, let's look at it. What kind of business problem is there? Is this process improvement, productivity improvement, cycle time, cost, or market? So same question as earlier, but now that you have more context and a discussion around it. So do you think it's a process of productivity improvement? Like, how many of you think it's a cycle time improvement?
I want to go for the process improvement.
You want to go for process improvement?
Yeah.
Yeah, I also for process.
All right.
Go with.
Yeah, I also go with process improvement.
Oh, so we have 4 process improvement.
I will also go with process.
5. All right. We still have 2 more. You haven't picked it up. What do you think it is?
Like, I'm not sure actually.
If you were to go with your feeling based on the discussion, where do you lean towards?
So it's process.
Right? Somebody online hasn't given their vote. What do you think it is? Afila, did you give your vote? Might have stepped away. All right. So you guys think it's a process improvement. My question goes back to servicing. What process you trying to? So read through it. Is there a product today? There is no product today, right?
Yes,
Currently, there is not a single commercial product that says that allows me to do this thing, right? So that means there is no process to it. If there is no product, is there a process? What they're saying is, if I go to a dealer and dealer says it's going to cost me X dollars, and I said I don't have it, his answer is tough luck. You bring the money and come back and I'll fix the car. That's it. That's end of discussion, right? Because there's no product exists that allows me to get the finance. So is there a process?
No.
You just simply said you have money or no. That's it. There is no process for me to fix my car at that point. Everybody with me? So it can be process improvement. Now let's talk about productivity improvement. Productivity improvement is usually tied with how effectively somebody can do their job, right? And can they do it more effectively or not? So whose productivity we are talking about? Dealer, lender, customer, outflow guy? Whose productivity we are talking about?
It's outflow.
Outflow guys? If I don't have a product, do I have anything? Am I productive at all? I don't have anything to sell. Can I even measure?
They want to like finance, so
But
they want
again, they want to finance, great. But the productivity improvement, I'm productive to do X thing today. Now you're giving me X minus or plus something, that's my improvement. I don't have a product to sell. What is my productivity? 0. What am I improving? I don't have any metrics to do productivity. Can I improve anything? You can't.
So like they have money that they want to give it to the market or the dealer.
Right.
So that is the product they want.
That's the product.
Yes.
But that means who is doing that product?
The dealer.
What metric you're measuring for productivity?
Mhm. Like if they're able to give more money, send more money to the market.
Send more money to who? Market? No. Is the upfront guy giving the money?
Yes.
No.
this is the first statement said company that is financing auto care.
I'm financing it, but that doesn't mean I'm giving the money. Who is giving the money? The lenders. Right? I'm just a platform provider to finance that. So I'm giving you an avenue to finance your repair. But I'm not financing it. Lenders are financing it.
So in this picture, like who's the lender? I don't, it's not hearing about.
So think about it. If you go to buy a car today, forget about the, do you think dealer is the one who is giving you the loan? Some bank is giving, right?
Yes.
But do you go to the bank to get the loan or do you go to the dealer? So dealer is financing for you.
Yes.
But the money is coming from a bank. And when you start paying installment, who are you paying? Are you paying to the dealer or are you paying to the bank? You're paying to the bank, right? Same concept here. Our loan guy is the broker. Who wants money? Dealer. Who is providing the money? Lender. What are you doing as our loan? You're connecting a lender and a dealer. Right? That's all you're doing it. So given that, is that a productivity improvement? I don't have a person working for me. There's no productivity for me. You know, you say dealer's productivity. Why do you think it's dealer's productivity? Are they going to fix the car faster? No, my technician is still going to take the same time to fix the car. Right? Is customer getting car any faster back?
No.
If he decides not to take the loan, he's still stuck with the not working car. So they are not improving any productivity there. The bottom line is, I'm the Airflow guy. Today, I'm not making any money because I'm not connecting dealers and lenders. So my market share is 0. Once I start connecting it to dealers and the lenders, I'm going to get probably more than a 0 transactions. Right? And then I'm going to make a money for every transaction. So my market share is going to go from 0 to something plus. Right? So this is all about improving the market share. Right? Because I don't have my process improvement, no productivity. Yeah, there is a cycle time, but I'm the guy who's paying money. My cycle time should be is how quickly people are closing transaction, the dealer and the lender. Right? I don't have that cycle time today. Cost reduction. Oh, no any cost. There's no product, so there is no cost. I'm building a product. Once I build the product, I will have a cost, but not till then. It's a market share.
So it's like the Expedia or whatever travel cities, right? Where you buy the tickets, but actually you are paying for the airline through the agent. The agent will get like a whatever the fee, $20 or $10 to book it. That's all. That's what the Airflow guys are trying to do for dealers.
It's a platform, right? So they make it money for transaction. Now, I want you guys to think for a moment. And that's why it's an important for quality assurance guys to think through it. All of you read the same document, right? Same paragraph. All of you interpreted it completely different. Right? Some of you thought it was process improvement, some of you cycle improvement. After discussion, you change your mind that it's a process improvement or productivity improvement. The most important thing is to, as a quality assurance, you need to understand what your customer wants. So whenever you read it, you're trying to analyze exactly what they're looking for. Because if you don't know what they're looking for, can you test for it? You can't. That's why it's important for you to understand what your customer wants. Okay. And that brings us to the analysis base, right? Because that's what's going to tell you what your customer wants. Before that, okay. Before that, what I want you to do is just spend 2 minutes telling you how actually the business problems, the planning phase happens. Okay, you read the problem. Right? So there are two aspects. Once you understand what the problem is, if you say you're going to build a system to solve that problem, you need to know 3 pieces of information. The first one is how much it's going to cost you to build a system, right? Second thing, you need to know how long it's going to take you to build a system. And third one is once the system is built, how much money it's going to generate or save, right? So what's going to be benefit? So anytime you have a business problem and you're trying to propose a solution to build a system, you need to make sure you meet these 3 pieces of data. What's going to cost me, how long it's going to take me, and what's going to benefit. Okay. So in a big companies, most of the companies, right, there is some sort of a governance committee, which involves the IT leaders and the business leaders. So if you have a proposal, you just take your proposal to them, they review it, and they make a decision whether your proposal is sound or not. Is it worth it to invest the money or not, right? And then they're going to decide, just like it, right? If I have only $100 and there is a competition and there's a proposal to buy things worth $500, I can't buy a $500 thing because I only have $100. So I have to make a decision. That means I'm going to have everybody say, tell me why your purchase is most important. Right? Tell me why I should spend $100 behind you and not behind this guy. That's the whole process. That's the business planning process. Now there are scenarios, right, where you put all that information and take it to them. They may say, idea is good, but you haven't considered all the factors for timing as well as from the cost point of view. Here are some of the other things I want you to think about, and based on that, recalculate and combine. But they may ask you to do some more iteration on your analysis. Okay. But at the end, they will either give you a yes or no decision. No decision means your project is canceled. It's not going to see a day of light. And yes means, yes, your project, the proposal that you did makes sense. We'll give you this much money. You go make it happen. Okay. So that's the business planning process. So we did this analysis, right? We just went through it, right? If you're using, say, it's going to improve market share, they will say, give me the data which tells you how much market share we will gain in, how much time, and how much cost it's going to take you to build that system to support that increase in market share. Okay, good. As a quality assurance, you will be asked to help to provide an estimate. Hey, what's going to take you, or how much it's going to take in terms of time and cost to validate or test the system. Right? So they may get an input from you, but as a quality assurance person, typically you are not the one who's doing all this work. It's either the leader or the project manager who will perform all this tasks. Okay, good. All right. Now, if they decide that we're going to move forward, right? What is the first thing you do? Say, hey, now let's just hash it out, the detail. What do you mean by building that system? Right? Same way, like I gave you an example of, hey, I want to build a house. Right? I figured out, do I have the money? Do I have a time to build a house? Yes? All right, let's go talk to the next step. What do I want in the house? Right? Outflow guy, yeah, you have the money. Now let's talk about what are you going to build as a system? Who's going to use it? How are they going to use it? What function and feature is going to be available? And what do you have to do? Right? That's the requirement. Okay. So requirements is nothing but the features of your system. They're going to build it to fulfill the purpose of the system. Right? we looked into our flow and they said, hey, I kind of define at a high level the process. This is what I want to do. So you can start defining the requirements from this. Okay. Now, depending on the view that you present for the requirements, it could be either a specification document or it could be simple requirements definition document. Okay. So if you list out everything from a customer's point of view, that, hey, dealer should be able to do this, or a lender should be able to do this, right? Then it's a user's viewpoint that you're doing it. That's a definition. What features they can do it. If you put it from a systems point of view, right? For example, system must validate the dealer's credentials. System must validate the lender did this, this, this in the system. Then you're putting that requirement from the system's point of view. Then it's called a specification document because it's meant for the people who are going to build the system. Versus the other one, it's meant for the user who are going to use the system. Right? Often you may see it one or both documents, or sometimes you will also see a document which is a combined version of it. Okay. But all of them are valid requirements documents. Now, when you talk about requirements, you can break it down into two categories. One is a functional, which talks about the behavior of the systems. And the other one is a non-functional, which talks about operational characteristics of the system. Okay. So for functional requirements, you have things like, hey, what I'm going to provide as an input, what output I'm going to expect it if I provide this input, and what is the processing logic it's going to have. And if there are errors, how I'm supposed to handle error. So let's give an example. If you're building a calculator, okay, simplistic example, and you said, hey, I want to perform a division operation. And you said, hey, what are your input? Right? Well, input will be two numbers or two integers and a division operand that will be input. What's the output you expect? Well, I'm expecting a number that gives me the answer, right? So it's great. That means if I do it, 5 divided by 2, I'm expecting output is 2. Right? Because I'm expecting the whole number. I'm not expecting 2.1. Now, if they say it, I'm expecting a decimal number and not the whole integer, then I can say it should be 2.5. You see it how the specification and the processing will give a different answer? Okay. Now, the error handling part. What if they provide only one number? Should you give an error message saying that please provide the second number? Right? How you handle it. Or if they give you two numbers, the top number in the division is 0, and say it's accepted, right? What if the bottom number is 0? You get an infinite, right? So you can say, hey, it's going to show me infinite as the answer, or it's going to do an error handling. It says you can have a 0 for the divisor, right? So depending on what your requirements are, right, and how they lay it out, it'll focus on input, output, or processing logic, or it will tell you how to handle errors. Okay. That will be your functional requirements, right? Same thing, you can just do it. Hey, what are the input, the loan number? What is the output? Well, whether it's approved or not. Something like that. And what is the processing logic, right? And you may say, hey, here are the 10 conditions it needs to meet. Now, non-functional requirement is essentially what is operational characteristics. Okay. So it could be, hey, from where they can access it. Can they access it from anywhere? Or they have to be in the dealer shop or a language, right? Or can I do it as long as there is an internet connection, I can access the app, right? It's a physical requirement. how many users it should be able to handle it. What are the operating hours? So is the system going to be up 24/7? Or is it going to be only up during, let's say, 7 in the morning till 7 in the evening? How long it should take it before, let's say if the system crashes, how long outage you can take it? You must bring it up within an hour. You must bring it right away. Okay. That's your operation characteristics. I worked on 911 systems when I was working at the U.S. insurance. There, the requirement is you can't go down because people's life is at stake. So you have to design such a way that even if one side is down, the other one automatically takes over. Right? It's a crucial in the time of disaster, right? So Hurricane Ida just hit it, right? Floods everything. Well, if somebody wants to call a 911, you still need to make sure that the call gets completed, irrespective of whether your data center is flooded or not. Then you have to build the system accordingly, right? Because everything has a cost associated with it. Versus if you say, hey, if the system is down, that's fine. Somebody will come replace the server and restart it, and you can live till then. That's okay, right? The cost is different. Now, the way I build it is different. And the way I test it is going to be different. Okay. Also talks about the security, right? You're talking about the financial numbers, so it's probably going to have people's social security number. You can't send it clear text, like it has to be encrypted. That's a requirement, and you validate that. So those all are non-functional requirements. And so you get an idea what is the difference between those two. Okay. Now, let's talk about as a quality assurance person. What do you do with those requirements? Okay. So somebody who is a business analyst or a project manager is going to sit down with the business users, going to compile all the requirements that they see that requires in the system, right? And they give you a document that says, can you tell me how long it's going to take you to test this thing, right? And how much people you needed to test this thing, right? So cost and the time. You have to first figure it out, right? So what do you do as a quality assurance first thing? So first thing, as soon as you get the requirements document, you have to validate, A, is it a complete document? Or it has all the requirements that you think you needed? And 2, can you test it? Right? So if somebody just says, it says, system must respond in a reasonable time. Can you test that? What is a reasonable time? If I'm running a huge report, reasonable time could be 5 minutes. But if I'm trying to complete a financial transaction, reasonable time could be 1 second, 2 seconds, right? So it's always contextual. What is a reasonable time for one user may be different than what the other user is. So how do you test it? You can't test it, right? Versus if somebody says that the transaction must complete within 3 seconds. Now, can you test that? Right? You can start the transaction, start the timer, and say how long it's taking to finish it. And you can clearly say yes or no. Did it finish in 3 seconds or under? Yes or no. Right? So now it's a testable requirement. So the first thing you do is a condition check, which talks about 3C and a T. The 3C is, when you look at the requirement, is this correct requirement? Second, is it consistent? And third one is it complete? Okay. So let's talk about the correct requirements, right? So when somebody says that this is a requirement, does it belong into the context of the business problem? Right. So if I take it, right, and give a requirement, the dealer is able to sell 5 different types of cars. If they put that as a requirement, What does that has to do with the auto repair? Nothing. Right? It's not correct. It doesn't belong here. Right? So you should ask the question, why is this in here? Tell me the context of it. Right? Second thing, it's consistent. So if they say, hey, the transaction should be completed within 3 seconds at one place. And then somewhere later in the requirements document, they say transaction should be completed in 1 second. Now, you have 2 contradicting requirements. Which one is right? Right. So that's what you should test it. Is it consistent throughout the document, or is it different versions? And if so, can you test it? No, right? Because you can think about 3 seconds and say, no, I meant 1 second. Well, how do you measure it? And third thing is completeness. If they say, look into the appendix to identify the information that you need to be encrypted and send it. And then there is no appendix. Is it complete at this point? No, right? Because it's missing data. Or they say it's look into such and such site for the financial standards to understand what data should be encrypted. You go to that site, there is no such site. Right? So it's not complete. So you need to make sure every requirement they gave you, does it belong into this problem domain? Is it consistent? Is it complete? Good. All 3 are there? Great. Now can I test it? It belongs in this domain. It is consistent and it's complete. But it's not testable. It's ambiguous. The example that I gave you, it should return the response in a reasonable time. Well, what does that mean? It's not testable, right? So you need to make sure every requirement that's listed in the requirements document that you get it as a quality assurance person meets this 3C and a T condition. Okay. If it's not testable, that's a problem. Okay. If it describes something that doesn't need it by a customer, it's not correct. It doesn't belong there. Okay. And then requirements are traceable. That means if you go ahead and take it requirement, start implementing, can you trace it down? Why did I implement this? Well, to fulfill that requirement. Right. So how do you go about collecting this requirement and understanding? Right? So when you looked at it, right, I gave you a problem definition. You read it. Probably you have 1,000 questions when you start reading it. Right? You try to ask those questions, read through the documents, does it answer it? If not, you ask the question. Right? But how do you go about that? So there are most common ways you meet with the customer to understand what they're looking at to get the clarity and the requirements. And there are various techniques that you can do. Right? You can ask a simple context-free questions, or you can go a whole bunch of different techniques. But some of them is, let's talk about your goals and benefits so I understand what exactly you're trying to achieve. What are your pain points? Who are the stakeholders, right? When we went through it, we just said, who is paying for it? Is dealer paying it? Is lender paying it? Is customer paying it? Or our firm paying it? Right? I want to understand who is the stakeholder? Who should I listen to? Who all I need to talk to? Who can give me this requirements? Okay. And then it contains a whole bunch of information on it. Okay. So here's what I want you to do. Okay, and then we're going to pause here for the day. Go ahead and look into your document, the 3rd tab. Remember I said the 1st tab is PowerPoint, 2nd tab is the exercise, and 3rd tab is a whole bunch of documents. And for online, Harshal has sent me an email. And I'm going to show you where it's at. Harshal, are you able to see this on the shared screen?
Yep.
Okay. So
page 7 to 71.
All right, so this is the first page for online people, and this is what I'm talking about. So when you, for the physical, when you open up the third tab, this is where you're opening. Okay. And there are 3 documents in that tab. The first one is this requirement specification document. The second document is the design document. And so you go so for online, if you go to page number 45, you're going to see it, Workflow System Design document. So if you keep turning your pages, you're going to see this document also. Okay, did you guys see this document? I think it's after about like 28 pages. Keep scrolling, keep going, keep going, keep going, going. Hang on, there you go. Go back the other way. That's a system design document. Okay. Did everybody find the system design document?
No.
Okay, got it? Got it. All right. So for online, it's you're on page 45. Okay. And then if you go through that document is about 27 more pages. Okay. And as long as you keep scrolling here, okay, on page 71, the document is going to finish it online. And if you see it, this is the last page, which is a signature page on the design document. Okay, and you know it's done when you hit this test plan document. Okay, so everybody reached to the end of the design document? All right. So what I want you guys to do is between now and Thursday, read the requirements document and the design document. Apply your 3C and a T practice that I just talked about, right? Correct, consistent. What is the third one? Complete. Right? Correct, consistent, and complete. And what does T stand for? Testable. Right? So you put in your quality assurance hat and read the requirements document. It says, do you understand that requirement? So if somebody tells you, test this thing for me, does the system meet or not? Can you do it or not? Okay. So if it doesn't meet 3C and a T, that means either it's missing part of information or you don't have enough information to test it. Right? So flag those. And we will talk on those on Thursday. So the way the Thursday session is going to be, it's online, is your homework is between now and Thursday evening. Finish reading that. Ask any questions that you have. Identify any requirements that you feel that's not testable so we can talk through it. So we're going to have Harshal, your business users or stakeholder. So you ask him any questions that requires clarification. The goal is you should be able to understand the document so that if somebody gives you the system that fulfills that requirement, you should be able to test it. Or at least you know what to test it.
I will also send out the link for a video recording for the prior discussion. So if you need clarification, right, you can watch that video at home from home. And then, so you have to read the document twice. Okay, both documents twice. First, just read it before you watch the video. Second time you watch the video and then read it again. And I think it will provide you a lot more clarification. But the goal here is because these are common type of project documents. Anywhere you go, they will help you. Hey, this is the requirement. This is the design. You guys come up with the testing side of things because you are QA. So you need to be able to understand what they are trying to build, what features from the software, and so forth. So the requirement document will give you a good idea about all the features. Okay, so I know you guys are looking at first time in your life. Don't get frustrated or anything. Just write down any questions, verification that you need, and we'll discuss on Thursday. Okay.
And let me tell you one thing. Before you end the project or before you end the class, you'll probably read it many more times. Okay. So expectation is not that you read it twice and you have everything memorized, you understand everything. That's not the expectation. The expectation is, when you start applying 3C and a T technique, do you understand that how to apply those techniques in the document? Okay. All right. Any questions? You all should have a Zoom link from Herschel for Thursday. It's a different than the one that you use it on the weekends. Okay, so when you look at it, just make sure you look at the Thursday, and it'll be at 6:30 on Thursday evening. Okay. Any questions before we wrap it up today?
So like the 3C what they have to test is like you have to check on everything.
Every requirement.
Every requirement.
Yeah. Does the document make sense to you? If somebody says that here's the system that fulfills the document, can you test it?
So the way I would read it, I mean, they would read it a little bit differently. Can I understand what they are trying to build here with the software? That's the first thing, first basic thing. What is the process flow here? How they are, what features, what are the things they are doing to bring customer on board, apply for a loan, and what is the process for approving the loan and so forth. So you need to be able to picture in your mind, build a picture in your mind, then what is the overall launching process and how the system will work.
Yeah.
And only you can test it.
And remember, like its system is going to be used by multiple different users, right? Dealers, lenders. You will hear a couple of other terms in there. So you need to think it from everybody's viewpoint. If it says, hey, if I'm a dealer and I log into the system, do I know what system is going to do it? Does everything make sense to me? Okay. Any questions online? Ophelia, Leela, are you guys good? Do you understand what we're looking for as a homework assignment?
Just reading these two requirement specification and the design document.
Right, and then applying
I'm
that
confused
to
now.
Unity.
Applying that with what?
With the 3C, which is the requirement complete, consistent, and correct? And then can you test it? Is it testable?
Okay.
Okay, any questions?
So we're gonna go through the
Yeah, this page. Okay. Once you finish reading those two documents, I don't want you to read the test plan document. Okay. That's something that we'll do in future after talking a little bit more and discussing more things about it. But for now, requirements and design document. Yes.
Actually, I'm not clear, like, when I'm reading all this stuff, like, I'm not clear what I'm supposed to do, like.
So when you look at it, right, this is all context, right?
So
But
from
then-
here, these are the requirements.
Yeah, this is, so remember the document, the way it is structured is there will be a requirement, but there will also be additional information that gives you the context,
Like business process.
right? What is the business process going to be used? And then as part of those business process, what are the rules? Right? And then there will be a requirement. So what you need to tell is, does those rules make sense? Right? So for example, do you understand what this business process is about? Do you understand what those rules are? Does those rules make sense? Is there a way you can test those rules in the system? And if so, does it meet 3C and T condition? Right.
So as I said, I mean, the video link I'm going to send you guys in the email. What that after you go through what the document, okay? That will help clarify a lot of things.
So think of this way. After finishing reading this document, right, your job as a quality assurance person is to validate if somebody builds a system and gives you a system and asks you a simple question, does that system build according to the specification? And if the answer is yes or no, is what all they're asking. That means in order to say that yes or no, what you're going to test into that system based on this document. And do you have understanding of what needs to be tested? That's all we are looking at the end of the day. Okay. So think it from their point of view. If the 3C and the T at every requirement, if it gets confusing, step back, think of that way, and then go back and say, okay, now that I understand, if they're saying this requirement, what would I will test in the system to see if this thing is fulfilled or not? Right? So for example, I think somewhere there is a requirement that certain type of users can create other users. Right? If somebody tells you, test it, what are you going to do? You're going to say, I'm going to log in as that user. And I'm going to try to create the other type of user that system said that it should be able to create it. Can they do this or not? Right? So if I'm able to do that, then the answer is yes, right? If I can't do that in the system, that means system doesn't meet this requirement. It's as simple as that.
I think that they will be fine. Today is the first day, right? So this is the first time looking at the document. See what you can get, okay? And we'll discuss on that. No, we will go through this process or whatever.
All right. If you a break for the day, and we'll see you on Tuesday or Thursday evening. Good. Right. Pause recording. Any questions online? Are we good?
Yeah, go ahead.
Hi, sorry, I'm still confused actually. What page number you said, 70? So till 70 we have to read all information. That's what you mean?
Yes.
So
you
from
read it-
1 to 70 we have to read all the instruction and then
7 to 17. So you start at page 7, which is the requirement specification document. You go through page 70.
okay, from 7 to 70.
Right. That will give you the overview of what system or project we're trying to build it that you need to validate in quality assurance.
Yeah. Okay, and then apply the 3 C's you
Apply the
say.
3C and T. Yes.
Yeah. Okay. Thank you.
All right. Have a good rest of Sunday. And see you on Thursday.
This will be important.